Hey everyone, welcome to the Advanced Computer Vision course. In this course, we are going to learn advanced techniques to better our skills of computer vision. Now, you might think that the term advanced might not be for you. Now, this does not mean that the topics are very difficult. It just means that they are on an advanced level, and we will do our best to learn it as simple as possible. We will break it down into basic code, and then we will create modules out of this so that we can use them in different projects once we are done. And we will be learning 4 different chapters, including hand tracking, pose estimation, face detection, and face mesh. And not just that, we will also be creating 5 different projects so that we can learn some real-world applications. For example, volume gesture control, AI trainer, AI mouse control, and a lot more. If you would like to see more of such content, do check out my channel Murta's Workshop, where we create projects related to computer vision, artificial intelligence, and robotics. So without further ado, let's get started. Hey everyone, welcome to my channel. In this video, we will learn hand tracking in real time. We will first write the bare minimum code to run and then learn how to convert it into a module so we don't have to write it again and again for different projects. The best part is we do not have to configure 100 parameters along with 20 different installs to make it run. Within 10 to 15 minutes, you will have your model working. The framework we will be using today is called the MediaPipe, which is developed by Google. They created these amazing models that allow us to quickly get started with some of the very fundamental AI problems, such as face detection, facial landmarks, hand tracking, object detection, and quite a bit more. So we will be covering the rest of these as well, so make sure to subscribe to keep updated. Now, the model we are working with today is the hand tracking. It uses 2 main modules at the backend. So one of them is the palm detection and the other one is hand landmarks. Now, the palm detection basically works on complete image, and it basically provides a cropped image of the hand. From there, the hand landmark module finds 21 different landmarks on this cropped image of the hand. To train this hand landmark, they manually annotated 30,000 images of different hands. So that is a lot of work. And this is one of the reasons it works so well. And the best part is that it is cross-platform and we do not have to dive deep into the sea of configurations and installations. So within just 2 clicks, we will be up and running. So let's have a look at the implementation. So right now I am in PyCharm and we are going to first create a new project. So you can see that I have created this hand tracking project, and we will go to File, Settings, and we will go to our project, then the interpreter, and we will add. So here we are going to add our packages. So we will write here OpenCV Python. We will install that, and then we will write MediaPipe, and we will install that. So these are the only 2 packages that we will be needing. So within 2 clicks, we are ready to start coding. So that is amazing. Okay, so now we will create a new file. We will call it, let's say, hand tracking minimum. So the bare minimum code that is required to run this. So the first thing we will do, we will write here import CV2, and then we will import MediaPipe as MP, and then we will import time. So this is to check the frame rate. So first we are going to create our video object. So we will write here CV2.video capture, and I'm going to use my webcam number 1. You can use your webcam number 0. So then we will write while true, and then we have success, and we have our image is equals to cap.read. So that will give us our frame. We will write CV2 dot wait key 1, and we will write cv2 dot IAmShow, and we will write here image, and we will write img. So this is basically what we always do to run a webcam. And what we can do as well is write here that if, or do we need, or we can skip it, it's fine. We don't need to write that we have to close with the Q button. So here we can right click and we can press the run button, and let's see. So there you go, this is my webcam, you can see my hand, there you go, and we are going to detect this hand. So the first thing we have to do is we have to create an object from our class hands. So here we are going to write, now this is related to the hand detection module, or the hand detection model. So later on we will create our own module so that we can learn how to use it easily in different projects. So getting the values of these different points or the landmarks is a little bit tricky, but we will create a module so that we can just say, I want the point number 5 of the hand. So tell me the location. So that will become quite easy to use in different projects. So first of all, we are going to write here mp hands is equals to mp.solution. Now this is, you can say, a formality that you have to do before you can start using this model. So you will write mp.solutions.hands, and then we are going to write that we are going to create an object called hands. We will write mp hands.hands, and then inside that we have to write our parameters. Now what are these parameters? So let's go and check them out. So we will click on, we will press the control button and we will right click on this, and it takes us to that function. So here we can check what exactly are we getting, what exactly do we have to input. So here the first thing is the static image mode. So static image mode, they have this configuration where they will track and detect. So if you put this as false, then sometimes it will detect and sometimes it will track based on the confidence level. But if you put it as static mode, then the whole time it will do the detection part, which will make it quite slow. So we will keep it false so that it detects, and if it has a good tracking confidence, it will keep tracking. So this way it will be much faster. Whenever the tracking confidence goes lower than a certain range, then it will do the detection again. So then you have the maximum number of hands. So here we have 2, and then we have the minimum detection confidence. So this is 50%, and then minimum tracking confidence, which is 50%. So it means if it goes below 50%, it will do the detection again. Okay, so now that we know our parameters, we can go back and we can write here false. So actually we are not going to write anything because these are the default parameters and they have already given the default values. So we do not have to change or write anything here. If we want to, we can. Otherwise, we can skip it as well. So for this instance, we are going to skip, and later on, we are going to write whatever we need. So then we are going to go, actually, we'll need to go back. Okay, so then here in the loop, we are going to send in our RGB image to this object. So here we have to first convert it. So we will write here image RGB is equals to cv2.cvt color, and then we will write our image. Why is there a double bracket? Okay, we will write our image, then we will write cv2.color underscore bgr to RGB. So this is our idea that we want to convert it into RGB because this class or this object only uses RGB images. So we need to convert that first. So we will write here that our results is equals to hands So we are calling this object dot process. So there is a method inside this object called process that will process the frame for us, and it will give us the results. So that's how simple this is. Now all we need to know is how to extract this information and use it. So after this, what we can do is we can simply display this, but at this point we are not really displaying or doing anything, but I still want to run it to see if everything is working so far. So it will be processing it, but it will not display anything for us. So let's try it out. So there you go. And now you can see, even though it's processing, the frame rate has not decreased. It seems real time. We will later on check the exact speed as well, the exact frame rate, so don't worry about that. Okay, so then we are going to open this object up, the one that we have received, and we are going to extract the information within. So as we have seen the parameters, we can have multiple hands. So what we can do is we can extract these multiple hands. So we will have to put in a for loop to check if we have multiple hands or not, and we have to extract them one by one. Now, before we do that, we have to make sure that there is something in the results. So we can print out the results and we can run it. And it just gives us that it is a MediaPython solution-based solutions output. And if I bring in my hand, nothing really changes. So we need to know when something is detected or not. So to check if something is detected or not, we can write here dot multi underscore hand underscore landmarks. So let's run this and see what happens. So here it says none. And if I put my hand, and there you go. So straight away, we are getting some values. So what we will do is we will say that if we can remove the print, or let's keep the print, we can copy this part and we can go down and we can write here, if this is true, then we are going to go in and for each hand, so we can say for each hand landmarks, let's say, in results dot multi, whatever we wrote here, multi-hand landmarks. So you saw that we were getting some results. So is it of one hand or two hands? We don't know. Well, we actually know because I just put one hand, but it could be of multiple hands. So here we will have each hand and then we will get the information or extract the information of each hand. So once we do that, we have a method provided by the MediaPipe that actually helps us draw all these points, because there are a lot of them and you have almost, how many were there? 21 points. And between each point, if you want to draw a line, it will be quite a lot of maths that would be involved there. So they provided us with a function or a method for that. So we are going to write that down. And that is basically mp_draw, we will call it mp_draw, is equals to mp.solutions, solutions.drawing utilities. So we will write that, and now we will use mp_draw to actually draw it. So we will write here mp_draw, and then we are going to write draw landmarks. And inside that, we will give in our image that we want to draw on. So we don't want to draw on the RGB image because we are not displaying the RGB image. We are displaying the original image, BGR. So we will write image, and then we are going to write hand LMS. So this is a single hand. Okay, so there could be multiple hands. This is, let's say, hand number 0. Then there could be hand number 1. So this is that single hand. So if I run this now, that should draw the hand for us. Let's try it out. And there you go. So now you can see it is drawing the hand for us. and it looks pretty good. So, but these are points, and I told you that we could draw the connections as well. So how can we do that? We can do that by writing here mp hands dot hand underscore connections. So that is it. So we are using mp hands dot hand connections, and this will draw the connections for us. So let's try that out. And there you go. So now you can see how easily we got our hand position, and we got all the 21 landmarks. If you like the video so far, give it a thumbs up and don't forget to subscribe. So this is good, but the problem is we don't still know how to use these values. So where are these values? How can I extract and use them? So for example, if I want to track one of these positions to perform a certain task, what exactly can I do? So that is still remaining, and we will learn how to do that. But before we go there, I want to do the frame rate. So we are going to write the FPS. So to do that, we are going to write here that our previous time is equals to 0 and our current time is equals to 0. Okay, so once we have done that, we will go down here, and before we display, we are going to write here current time is equals to time dot time, and this will give us the current time, and then our FPS will be 1 divided by our current time minus the previous time. Okay, so then our previous time will become the current time. Our previous time will be the current time. So yeah, that seems good. And what else can we do? Yeah, I think we should display it on the screen so that we can see it rather than putting it on the console. So we can write here cv2 dot put text, and we want to put it on our image. We want to convert it into a string because it is time. So we are using, what do we call, FPS, and we also have to round it because, or should we, if we round it, it will give us decimal values. We don't want decimal values for FPS. We can just put integer. So that will give us that, and then we can give it a value, the position, let's say 10 and 70, and then we can give in our font, cv2.font, whatever comes first, and then we write the scale, and then we write the color. So let's put purple, or let's put blue, whatever, let's put purple. And then we have the I think I missed something. I missed a comma here. Okay, and then we need to put, I think, the scale or the thickness. The thickness, let's put as 2, or let's put as 3. Okay, so that seems good. And what else? I think that should be fine. Let's run it. So here we have it. So now we can see that the time is around 30 FPS. The frame rate, it goes to 20 sometimes, but most of the times it's 30. You can see it's quite fast, very responsive. Thumbs up. Oh, thumbs up makes it go away. Thumbs up. Yeah, this time it worked. Thumbs up. Great. Let me try my other hand as well. So that seems fine, and it is working quite good. So we can move on. So now we are going to get the information within this hand. So for each of these hands, so we will get the ID number, and we will also get the landmark information. So the landmark information will give us the X and Y coordinate, and we also have their ID numbers, and they are already listed in the correct order. So all we have to do is we have to check their index number, and that's it. So what we can do is we can write here for ID and the landmark, we are going to find it, or we are going to enumerate, and then we are going to find it inside the hand LMS dot landmark. So this is basically our landmark. This is basically our landmark that we are getting from here. And this is the ID number or the index number that we are getting, which will relate to the exact index number of our finger landmarks. So if it is 0, it will be the bottom middle one. Then if it's 4, it will be a tip and things like that. So what we can do is we can print here and we can write ID and landmark. So we can see at least what is happening. So let's run that. And there you go. So let's see what did we get. So if we go up here, you can see that this is ID number 20, 19, 18. So if we keep going back, we will start from 0. So each ID has a corresponding landmark, and the landmark has X, Y, and Z. So we are going to use the X and Y coordinates to find the information or to find the location for the landmark on the hand. But the thing is, if you see here, these values are decimal places. So the location should be in pixels. So it should be, for example, 500 pixels in the width and 200 pixels in the height, something like that. But here you can see these are decimal places. So basically what they are giving is they are giving a ratio of the image. So we will multiply it with the width and the height, and then we will get the pixel value. So this is how we can get it directly. So here what we are going to do, we are going to first check out the height, the width, and the channels of our image, which will be image.shape. So we can write this, and this will give us the width and height. And then what we can do is we can find the position. So we can write here CX and CY is our position of the center. And basically it will be an integer because it is decimal places. So we have to convert it into integer. So we will multiply our landmark dot X value multiplied by the width. And for the second one, it will be integer and then landmark dot Y value multiplied by the height. So this will give us the CX and the CY position. So now we can print this out, but the thing is that it is not for a specific one. It is for all of them. So if we print it now, let's remove this and we will print CX and CY. So if we run this now, it will give us for all 21 values. So how do we know which one is for which? Which one is for landmark 1? Which one is for landmark 2? So we need to write the ID of that as well. So we can write it like this. So there you go. So now we have this information. So if we look here, this is the ID number and this is the CX and the CY position. So what we can do is we can use any of these to actually use it to our benefit to actually print out any of these landmarks. So I can write here if ID is equals to 0, this means we are talking about the first landmark. Then we are going to, let's say, draw the circle. So we will write here cv2.circle. We are drawing it on the previous one and we will color it a different way and we will make it a little bit bigger so it is easier for us to know that this is the one that we are printing. So it shouldn't be an issue. So we can write here that our radius is, let's say, 5, and then our color will be different. It will be purple. And then we have cv2.filled. So once we have that, now it will only draw for what do you call the ID number 1. So if I run this now, and there you go. So you can see here at the bottom, you get, okay, let me make it bigger. It's very small. So let's make it 25. There you go. So now you can see clearly that we are detecting that landmark, which is 0. So if I remember correctly, 4 is a tip of one of the fingers. Let's make it 15. 25 is too big. There you go. So it is the tip of the thumb. So you can see now we are getting this information. And what we can do is we can put all of this in a list, and we can use it to print, or we can use it to find the location and move around and do all sort of different things with this. What we can do is we can also remove this, and then it will draw on all of them. But that's not useful because we are already drawing on all of them. So here you can see, looks quite weird. Anyways, so that is the basic idea, that this is how you get the CX and CY information, which is basically for each one of these. And we can put them in a list so that we can later on return this list and use it to our benefit. If we want to track the index finger, the tip of it, or the bottom part of it, whatever we want to track, we can do that. So now that we are done with this, we are going to create a module out of this, so that next time if we are using it in a project, we don't have to write all of this again. We can simply ask for the list of these values, of these 21 values of each hand. For example, we can say, give us for the first hand, give us for the second hand, whatever. And then we can simply say, okay, I need point number 10. And it will give us the value of point number 10, which is, let's say at this point, it is 444 and 210. So that will make it very easy for us to create new projects. So let's see how we can do that. So now we will create a modules file. So here we will call it hand tracking module. So we will copy pretty much all of this code and we will paste it here. And first of all, we will write here if name is equals to main. This means that if we are running this script, then do this. So whatever we write in the main part will be like a dummy code that will be used to showcase what can this module do. So we will write here def main, and we are going to put our while loop inside of this. So while true, and in fact all of this as well. Not that. Let's copy this part first. So we'll put this here, and then this part here also. For the frames FPS, we will put it down here. And what else? What else do we need? Yeah, the video capture. We can put it here. Wait, why did it show here? Okay, I think I copied it or what? Yeah, so we need to remove this. Okay, and then what else? What else? I think that is fine for now. So now what we have to do, we have to create our class. So I thought of doing it in functional programming, but I think it will be better if we create a class. So we are going to create a class here. We will call it class hand detector, and inside that we will write def init self, and inside that we have to give in our parameters. So these parameters are the basic parameters that are required for this hands. So if you remember, we went to the hand and we have all these parameters. So these are the ones that we will be using to input that. So that we have the flexibility of changing these. So here we have the mode. So we will write here mode is equals to false. Then we are going to write the max number of hands. So we can write here max hands is equals to 2. Then we can write the detection confidence is equals to 0.5, and the track confidence is equals to 0.5. So then we can remove all of this. And now the first thing we have to do is we have to write self.mode is equals to mode. This means that we are going to create an object, and the object will have its own variable. So this is that variable. Whenever we are using the variable of the object, we will call it self.something. And we are assigning it, initially we are assigning it a value provided by the user. So we are calling it mode, and we are providing it the value of the mode. So the same thing we have to do with the other parameters. So we will write here max hands is equals to max hands self dot detection confidence is equals to detection confidence self dot tracking confidence track confidence is equals to track confidence. And then all of these have to be inside this initialization as well. So if you remember, they are part of the initial code where we are initializing everything, and then there is the while loop. So we need to initialize these as well over here. And again, we will write here self dot. So we will keep putting self dot everywhere. And we also have to, so why is this giving an error? MP hands, because we need to add the self here as well. So we will write here self.mp hands. So that should be good. And inside that we have to give in our parameters. So the parameters will be self mode, then the max hands, the confidence, and the tracking confidence. There you go. So this should be fine. So I think the initialization is done. So now we can move on to the detection part. So we can write here, let's say we will call it find hands. And inside that, we have to just copy this part. So do we need to convert? We do need to convert, and we need to put this as well. So we will put all of this, we will put it here inside. And then we will go back up here, and let's start from here. So first of all, we will need an image to find the hands on. So that will be this image, and then hands is not being recognized because it has to be self.hands. So we are talking about this object within this object. So then we have mp.draw. So this should be self.mpdraw, and then self.hands connection. So that should be good. And should we draw it inside? I don't think we need to draw it here. In fact, we do not even need to get the landmarks from here. What we can do is we can keep this outside and we can comment this. So here, this is what we need basically to draw the hands. So we can put a flag here. We can write here draw, and we can put it by default as true. And we can check if we want to draw or not. So here we can write here if draw, then do this. Okay, so it will only draw if we ask it to draw. So I think this is good enough to actually run the code or run the class without actually getting the list. So for testing, this should be fine. So what we can do here, so we will create a new method within this class that will find the position for us. It will give that list for us. But for now, we will just test to see everything is working so far or not. So here we will first create our object. We will call it detector is equals to hand detector. And we will not give in any parameters because we know that we have these default parameters already there. So once that is done, we will get our image. And once we get the image, we are going to send this image. We are going to write here detector dot. Now this is the method here, find hands. So this is the method within our class. So we will write here find hands, and we have to give in our image. So that is the most important component. So we might need to draw on it. So we need to return the image if we have drawn on it. So we will return the image. So then we can go back and take the image over here. So image is equals to this. So if we run this now as a module, it should work. So let's see if we did any mistake. Yeah, it's working. Oh yeah, that's good. So now our module is running. The main reason for creating this module is to get those position values of the landmarks very easily. So we need to create that find position function or the method. So we will write here find position, and we are going to give in the parameters of our image. Now we don't really need the parameter of the image, but we need it for the width and the height. So if you remember here, we need the shape. So we can do it in other ways, but this is simple. So we will try it now. Later we can improve on it. Then we need the hand number. So if you're detecting with, if you want the information of hand number 1, hand number 2, hand number 3, whichever hand you want, you can ask the information of that. And then we will have the parameter for draw. So again, we will put it as true by default. So now we can uncomment this and we can bring it back. Okay, so that should work. Now here the issue is that we were using a for loop to actually run this, but now we need to first check again. We will go back here and we will create a list here, LM. This is the landmark list that we are going to return. So this list will have all the landmark positions. So we can return this, whether it is filled or not, we will return it. So we will return this, and then we are going to check again that whether any landmarks were detected or not, or any hands were detected or not. So to do this, we use basically this part here. So if the self results, multi-hand landmarks, if that is available, then we are going to check the next things. So here we will write this, and we will put all of this inside that. So, but here we are getting the results. This is the results. It should be self.results. Self.results. And now I can use the results here as well. Okay, so no, we need to replace this here as well. Okay, so if it's not self, then I cannot use it in this method. To use it in all the methods, you have to make sure this is for this object, this variable. Okay, so now we have to write down that which hand are we talking about, because earlier we were getting it for all the hands. So if you want, you can get it for all hands, it's up to you, but I'm creating this method to get the for one particular hand. If you want, you can change that too. So here we are going to write, so earlier we had 4 hands, this. Now we will get this and we will point to a particular number, and that number will be the hand number. So we will say that our let's say our hand, let's say we'll call it my hand, is equals to this, and we will put this over here. So it will get the first elements, the first hand, and then within that hand it will get all the landmarks and it will put them in a list. So here we are just printing them out. So here we can write lm lists list dot append, and we want to append the values of id, cx and cy, and we can remove the print because we're getting it anyways. So yeah, so that is, I think that is good. And here we have the option of draw as well. So we can write here if draw, then do this, otherwise don't. So by default it is true, so it is going to draw. So yeah, let's see how that works out. So we can return this list. So I can call this, so we can go down here and I can call find position, and we can remove the self, and we have the image. And do we need anything else? I don't think so. Okay, copying this was a bad idea. Anyway, so finding position, self, image, yeah. And it will give us the list, so we can copy this and we can paste here. So now what I can do is, by the way, we have to write detector.find position. So now what I can do is I can print the value of my list at any index. So if I want, let's say the 0 index, then I will write here 0. If I want the landmark number 4, I will write here 4. So if you remember, the 4 was the tip of the thumb, so this will give us that position. So let's run this and see what happens. Index is out of range. Okay, so that is understandable. Why? Because here we have to check if nothing is found, which means lm list, the length of it is 0. So we will write here that the length of this list is 0. Then we will, if it's not equals to 0, then we will print. So let's run it again. And there you go. So if I put my hands, so now you can see it's drawing for all of them, but it is showing me only landmark number 4. So if you look at my thumb, if I'm going really to the, okay, it's not moving the values. Okay, so now if I go till the very end, you can see it is 600 something, because the value is 640, the max value. And now if I go around to the starting point, it goes around 150 something, 200. So I'm talking about the X position, by the way. So the X position is changing like this. Then we have the Y position. Here it is going towards 0. And down here, if we go down here, it is going towards 400 something. So this is a 640 by 480 image. It works well with 1280 and 720 as well. So it's still around 20 something frames per second. So that is quite good. Okay, so now this is working as a module, and what we can do is we can use this in a different project. Now you might say, how can we do that? Well, here is the dummy code. So this dummy code we can use to actually run in a different project. So I can copy this and I can create, let's say, my new game hand tracking blah blah blah. Okay, that's a very long name. So I can paste this here, the complete code, and I can remove the indentation, and then I can import these. So then I need to check what is missing. So here now I need to import, I will import hand tracking module as HTM. So now I will write HTM dot hand detector, and the rest will remain the same. So that is pretty much it. So if I run this now, it should run exactly the same. So there you have it, and there you go. So now it's giving me the values of the index, not the index, the tip of the thumb, which is landmark number 4, and it is showing me all the landmarks as we have drawn. So if I go back here, if you like the video so far, give it a thumbs up and don't forget to subscribe. To my module, I can change the color, or I can change the size of these as well. Again, all these parameters you can change, you can add to your methods if you wish, and it could become easier for you. It depends on your project. So if you have a lot of different things that you want to accomplish within one project, then you can add more methods to this to compensate for that. So here, let's say we will make it a little bit smaller. So 15 is too big. We will make it 7, let's say. And let's change the color. So it's BGR. So let's make it blue. And there you go. So now we have changed it. And if we go back, actually I preferred the previous one, even the big aspect. So here what we can do is, if you don't want to show it, we can write here false, and it will not display. Oh, it's displaying. Wait, why is it displaying? So why is it displaying? Let's go back here, and if draw, then only we do this. Okay, maybe it's drawing here as well. Am I running this? Yeah, I'm running the correct file, but when I write false here, oh, there are more arguments. That's the problem. There are more arguments, so we cannot just write here. We have to write draw is equals to false. My bad. Draw is equals to false. And there you go. The drawing is gone. That the custom drawing that we did. Now, if you want to remove this drawing as well, you can write here draw is equals to false. And there you go. So now you will see that you are getting the value of the thumb, but nothing has been drawn. So this way you can customize it to your needs. Hey everyone, welcome to my channel. In this video, we will learn pose estimation. We will detect 33 different landmarks within a human body, and all of this will be done in real time. That's right, more than 24 frames per second and only running CPU. We will first look into the basic code required, and then we will create a module out of this so that we don't have to write the code again and again. And yes, we will be creating a lot of projects with this, so don't forget to subscribe and hit that like button. So here we are in our PyCharm project, and you can see that we have named it Pose Estimation Project, and we have a folder here with pose videos. So if I open this up, you can see that we have a lot of different types of videos. We have a total of 9 videos. So let me play a few. So here you can see this one is a little bit smaller. And some of these videos are actually slow motion. So when we are running it, it will look like it's slow, but it's not actually slow. It's actually slow motion. So like this video, and then I think, what else? I think this video as well. It's slow motion. And I think this one is fine. Yeah, this one is normal. This one is slow-mo as well. So I took these videos, I think from pexels.com. So we are going to test these videos out and see how well does our pose estimation work. So we will select all of this, or let's create a new file. Let's delete this one. So let's delete this, and now we are going to create a new file, and we will write here pose estimation minimum. So this is the bare minimum code that is required to run it, and later on we are going to see how we can create a module out of this so that we don't have to write the code again and again for a lot of different projects. So let's start by importing CV2 and then importing media pipe as MP. But now you can see that we get an error. This is because we did not include these packages in our project. So how can we include those? So we will go to File, Settings, and we will go to our project interpreter and open that up. And here we will write opencv-python, and we will hit install. And then we will write media pipe and we will hit install. So now both the packages have been installed, and we can go back and you can see the error is now gone. So OpenCV is the library that we will be using for image processing, and MediaPipe is the framework that will allow us to get our pose estimation. So now the first thing we will do, we will read our video. So we will write here cap is equals to cv2.video capture, and we will simply give in our video number. So here we will write pose videos, and we will write video number 1.mp4. I think the one is quite big. Let's try it out, and later we can change it if we want. And then we will write while true, and we will write success, and image is equals to cap.read. So that will give it our image, and then we can write here cv2.imshow, and we will write here image, and then we will write here image, and then we will write cv2.wait key, and we will write 1 so that we give a 1 millisecond delay. Okay, so let's run this and see if it works. And there we have it. So our video went quite fast. So the frame rate is actually quite high at this point. What we can do is we can check the frame rate by writing here time. Let's say current time is equals to, we need to import time as well. So we will write here import time, and then we will write time.time. Then we will write that our FPS is equals to 1 divided by our current time minus our previous time. And our previous time is equals to current time. And we need to define the previous time up here at the top. So we will write here previous time is equals to 0. And then we can simply put our text. So we will write here put cv2 dot put text, and we will write in our image, and then we will write in the text itself. So we will write string fps, but we will convert it into an integer before we do that. Then after that we have our origin, so let's say 70 and 50, and let's say the cv2 dot font plain, and let's say 3, and then for the color we can put 255 0 and 25 and 0, and then we can put 3. So this should give us our frame rate. Let's try that out. Wait, what happened? Okay, this should be below over here, my bad. So let's run it again, and there we have it. So you can see it's 100 something frames per second, so that's quite a lot. If we want to reduce it, we can put here, let's say 10. So now it's like 50-60 frames per second, but when we are using our model, it will automatically slow it down, so we don't need to worry about that. So the next step would be to create our model, so our object, so that we can detect our pose. So here we are going to write mp pose. Pose is equals to mp dot solutions dot pose. So we are going to use this, and then we are going to create our object. We are going to say pose is equals to mp pose dot pose, and then we will give in our parameters. So if we go to the parameters, you can see that we have the static image mode. This is basically that when you are detecting and when you are tracking. So if you put it as true, then it will always detect based on the model. It will always try to find the new detections. But when you put it as false, it will try to detect, and when the confidence is high, it will keep tracking. So there will be a tracking confidence, and then there will be a detection confidence. So whenever it detects, if the confidence is more than 0.5, it will say, okay, now we have detected, now I will go to tracking. Now the tracking will check. If the tracking confidence is more than 0.5, it will keep tracking. Whenever it goes below 0.5, then it will come back to detection. So this way we do not use the heavy model again and again for detection. Instead, we use detection, then tracking, then whenever it's lost, we use the detection again. So this is what this does. And then we have the upper body only. So you can decide if you want to detect only the upper part. So it will have, you can see here, we have 33 poses, landmarks, or only 25. So it's up to you which one do you want to use. And here we also have a feature to smooth, which is by default true. So we will keep it as true. So we can define all of these parameters, or we can skip them. It's up to us. So for the initial purposes, we are going to skip all of these for the simplicity. So then we are going to go down here, and simply we are going to convert our image. So we will say image RGB is equals to cv2.cvt color. So this image is in BGR, but this library or this framework uses RGB. So to make it compatible, we have to convert it. So we will write here image, and then we will write cv2 dot what color underscore BGR to RGB. So this is our conversion, and once we have done the conversion, we are simply going to send this image to our model. So we will write here results is equals to pose dot process, and we will write image RGB. So that's pretty much it. So that will give us our detection of our pose, but it will not draw anything. But for now, we can just run it to see if everything is working. And now you can see that the frame rate has decreased. So this is good to see that our model is actually working. But you can see that it's almost real time. So that is really good. So now what we can do is we can draw our landmarks. So whatever we have detected, we can draw it. But before we do that, we can print the results as well. So we can write here results and let's see what do we get. So here you can see we get nothing. So it's just a class, but we don't see any information. So how do we see the information? We simply write results dot pose landmarks. Landmarks. So if we run that, now you will see that we are getting actual landmarks. So each landmark will have the X, Y, and Z value, and then it will also have a visibility value. So how visible is it? So this is the information that we get. So we can put all of this in a list later on so that it's easier to access. So then we will check if it is detected or not. So we will say that if this is present, if this is true, then we are going to write here that mp draw landmarks, draw underscore landmarks, and then we are going to define our parameters. But here you can see we don't have anything called mp draw. So we are going to declare that. We will write here mp draw is equals to mp.solutions.draw utilities. So we will use that, and then we can write here within our landmarks, we can send in our image. Then we can write results dot pose landmarks. So this is the same thing that we are printing out that we got. So we will write here landmarks, and then what do we have? I think that is good. Let's do that. Let's run it. And there you go. So now you can see we are getting all the points. You can see that it is in red. Now what we can do is we can also add the connections or the lines between these. So here we can write mp dot pose connections. So that will fill up the connections. There you go. So now you can see we have the green lines, which are the connections, and then we have the points as well, and we are detecting them all at real time. So that is very, very amazing. So now we know that we are getting this information, but how can we know which is for which? So here it just says landmark this, landmark this. There is no indication of which landmark represents what. So what we need to do is we need to organize a little bit so that it is in a list and we can simply use these values in our project. So for example, I will say I want landmark number 5. I want landmark number 3. So if we go to the MediaPipe website, you can see here that these are the landmarks that they have given. So for example, if I want the right ear, so I can just say I want the element number 5, element number 8. So give me that element. If I want the nose, I can say give me the element number 0. So based on this, it will become very easy for us to actually create our new projects. So gesture recognition and lots of different applications will become very, very easy. So how can we extract the information within this object? So what we can do is we can write here for ID and landmark in enumerate, we will write this result. So we are going to loop through this, and we want the count as well. That's why we have written enumerate. So it will give us the loop count over here. So 0, 1, 2, 3, and so on. Then we are going to get the shape. Actually, this will be, we have to add here landmark. And then we are going to write here height, width, and channel is equals to img dot shape. And the reason we need this shape is because, let me actually show you why and you will understand. So what we can do is we can write here print, and we can write lm.x, or let's just print lm so you can see what is happening. And we can print the ID number as well, so you know what exactly are we extracting here. So let's run this. So there you go. So now you can see we have the ID number, and this is the information of the landmarks. So 30 is this, 21 is this, and it goes all the way to, wait, why is this showing? I think I didn't remove the other print. Anyways, so you can see here from 0 to 32, we will have all these 33 landmarks. So let's go down and let's just remove the previous print first. Okay, so now we know that we have the ID and we have the landmark, but you can see the landmarks, they are actually in decimal places. So this is basically a ratio of the image. So what we can do is, to get the actual pixel value, we can say that lm.x, this will give us this x value multiplied by the width of the image. So that will give us the x of our, what do you call, the point or the landmark. So it will give us the exact pixel value. The same thing we can do for lm.y, and we can multiply it with the height. So we can do that. And then what we can do is we can put them in our cx and cy variables. So this way it will be easy for us to use. The indentation is wrong. That is why it's giving an error. Okay, so also we need to convert this into integer, because we have to make sure it's not a float or a double, because we are talking about pixel values. So then what we can do is, to confirm that this is happening and we are getting the correct values, we can simply print the circle on top of this point. So we can write here cv2.circle, and in the circle we will write image, and then we will write cx and cy, and then we can write, let's say, the value of 15. 15 will be too big. Let's say 10. Then 255, 0, 255. This is purple. Let's make it blue. And then we will write cv2.filled. So this will overlay on the previous points if we are detecting it properly. So let's try it out. So there you go. So now you can see we have those blue dots, and these are the ones that we put ourselves. So this means that we are getting the correct information at the correct pixel values, and it is working good. We can reduce this to 5. There you go. Much better. Actually, let's try another video. We have been using the same video. We have like 9 videos. So let's try a random one, number 5. Yeah, that looks good. Let's try number 6. Yep, that is good. Number 3. There you go. Okay, here we had an issue, but now it's fine. That's good. So we can see that we are getting good results, and that should be good enough for us. So next, what we can do is we can convert this into a module so that we can use these values very easily. So the first thing we will do, we will go here and right click, and we will create our module. Let's call it pose module. And we will copy all of the bare minimum code and we will paste it here. So that looks good. Now the first thing, to make it a module, we have to write here if __ name is equals to __ main, then we are going to write main. So what this does is that if we are running this by itself, then it will run the main function, and if we are just calling another function, it will not run this part. So this is what it means. So we will write here main, and within the main we are going to write everything, or we will write the dummy code in the main. So whenever you want to see what a module is capable of, or the testing script, you can put it in the main function. So here we will take this till here. We will cancel it from here. We will cut it and we will paste it in the main. Then we will take all of this as well. We will cut it and paste it in the main again. So that should be good. And what else? So now we are going to create a class. So in that class, what we should be able to do is we should be able to create objects, and we should be able to have methods that will allow us to detect the pose and find all these points for us. Okay, so here we are going to say that our class, let's say, is pose detector, and inside that we will have our first method, which is the init. This is the initialization. So we will write here init self, and then we are going to write in the parameters that are required. So whatever parameters we are expecting, we will write here. So here we are going to write mode. So if I go to, where is it? Okay, let's go to pose estimation, and here we are going to go to pose. So I will copy all these parameters and we will just paste them here, and we will write. So the first one is mode. So we will keep it as false so that we get fast detections. Fast detection plus tracking. And then we will write here upper body. So upper body is equals to false. And then we have the smoothness. Smooth is equals to true. And then we have the detection confidence is equals to 0.5, and then we have the tracking confidence is equals to 0.5. So these will be our initial parameters, and then we can remove this, and then we can write here that self.mode is equals to mode. Now, if you're not familiar with object-oriented programming, then this basically means that whenever we create a new object, it will have its own variables. So this, whenever you write self.something, it is the variable of that object. So whenever we are using a variable within our class, we will write self.something. So self.objects, self.mode, self.upbody. So we are going to write that. So here we are saying that the specific variable of our class or our object is basically the one that the user has provided. So it will set this instance of that object to false. So this is what it does. So here we will copy all of these and we will write up body is equals to up body, and then we will write smooth is equals to smooth, and then we will write detection confidence is equals to detection confidence, and we will write track confidence is equals to track confidence. So as I mentioned before, we just have to put self dot in front of each one of these, and that should be good to go. So next we also have to declare these. So again, this will be part of that object. So we need to write self. So here we will write self.draw, self.mpose, and self.pose. And we will write here self.mpose. So this is good. And what we can do is, earlier we were not using any of these parameters, but now we have to. So here we are going to send in all the parameters. So we will write here self.mode. So self.body, self.smooth, self.detection confidence, and self.tracking confidence. So that is pretty much it. Okay, we need to put a comma here. And yeah, so our initialization is pretty much done. And now what we can do is we can create a method to find the pose. So we can write here find pose, and we do have to write self here. So whenever we are creating a new method, we have to write self first, and then we have to give in our image, and then we will also have a flag called draw, and we will put it as true. So this basically what it will do is it will ask the user, do you want to draw or not? Do you want to display it on the image or not? So we want to display, so we are going to put this inside here, and then this draw, if results draw this, yeah, this will be separate. This for loop will be separate, and this results will be here. So let's push this in, and we can remove this. And what else? So now we need to write the self dot. So here we will write self dot pose process and self dot mp draw. Then we can also write self dot mp pose. So anything missing? No, it seems fine. Now what we need to do is we need to put that flag. So we will write here if draw, then we basically do this. So that should be good. So let's try it out. Or should we put it inside? Let's put it inside that. So we will say that if landmarks are present, or let's put the draw inside. So if the landmarks are detected and we said draw, then you need to draw. So that is good. So by now we should have a working class, so we can create an object from it and then we can run it. So let's try that out. So here we will write our detector is equals to our pose detector, and we will give in the default parameters. And here, what is happening here? This should be inside the while loop. So here we are going to write detector dot find, what was it, find or detect? Find pose. Find pose. Why is it not detecting? Oh, the indentation is wrong. So now it will detect. Okay, so detector dot find pose, and then we have to give in our image. So that should be it, and we need to return the image. So we will write here return image, and we can bring in the image back here. So if we run this, it should draw on our video. So let's run the pose module, and there you go. So now it is running and it looks good. Let's try it on the first image. There you go. So this is quite good. And what we can do next is we can do the main part, which is to find the points. So we need to get those points. Here we are going to define the get position, and we will write inside that we want an image, and then again we want the draw flag. So by default we are going to, yeah, let's put it as true, and then we can uncomment this. Okay, so now what we will do is we will, first of all, here we are getting an error for result because we need to write self.results here and here and here and here. Okay, so that should be good. And what else? So we need to push this in the for loop. So now we are just looping. We need to check first as well if the results are available. So if the results are available, then we will use this for loop. And then we need to put it in a list. So we are going to write a list, lm list, which is for our landmarks, and we will append our values. So here it depends on you. What kind of values do you want to append? So I'm going to append only the X and Y values and the ID. If you want to append the Z and the, what was the other one? The visibility, you can do that too. So here I will write lm list dot append, and I will write in the ID. So here I will write ID, and then I will write the CX and the CY. And I will add the option here that if draw, then do this. So this looks pretty good. So let's go down and try it out. So where is it? Here. So we can write here that our lm list is equals to detector dot find position. Is it find position or get position? Let's keep it find position, so it's similar to the previous one. Find position, and then we will give in our image, and let's keep it as true for drawing so we know it is detecting. And we can print out the list as well. So we can print out lm list, and there you go. So now you can see we are, wait, why is it printing this? That is not right. Okay, this is printing this parts. Any other prints? No. So let's run it again. Yeah, so right now it's none. Wait, why is it none? The lm list is none. Lm list, oh, we didn't return it. Forgot to return lm list. Okay, so now we can run it, and there you go. So now we have the list, and if we go till the end, you will see we have a total of 32 points. So we have 33 points because we are starting from 0. So now I can easily say, for example, I want number 0, I want number 8, I want number 5, number 23, whatever I want, I can write down here. So let's say we want number 8, or let's say we want number 14. Let's try that. Number 14. And there we have it. So this is the number 14. And if I wanted to, I could draw this number 14. So I can put this as draw false, and then here I can write lm14 at 1 and 2. So this will be 1 and this will be 2. And I can make this really big so I can see what exactly am I tracking, and I can change the color of it so that it is a little bit different than all of these. So I can put it as red. And there you go. So now you can see we are tracking this elbow. So this is how easy it can be. By the way, whenever it finishes the video, it will give you an error. You can loop through that. There's a function for that as well, but we're not going to do that. So this is the basic idea of how you can convert this into a module. And now you can use this in any project that you want, and you can easily find the position. So how exactly can you do that? So let's create a new file, and we will call this our awesome pose project. So we will copy the parts from the main. So as I said, this is the testing code. So we will copy all of that and we will paste it in our awesome project. And now we have to import. So we will write here import CV2. And then we have to import time. And then we have to import our module. So our module needs to be in the same folder. If it's not in the same folder, it will not work. So you have to write import pose module as PM because it's a smaller name. So we can write here PM dot pose detector. So this will create the detector and everything else will run the same way. So if we run this now, our awesome project, and you can see it runs exactly the same way. So now I can use this in many different applications. So one thing we can do is we can test some other videos. So let's say number 2. There you go. Again, we are detecting the right elbow and you can see it's tracking really well. That's pretty awesome. Even when it's a little bit hidden, it's still tracking it. That's really good. And then let's try number 3. What happened to number 3? There's an error. List index out of range. Okay, so yeah, this is a problem because we are not checking if actually the list is filled or not. So we need to check if lm list is not equals to 0. Actually, the length of it is not equals to 0. If the length of this is not equals to 0, then only we can do these two things. So actually we should change that at the main module as well. So where is it? Here. So let's run the awesome project again. And this time it works. So probably the first frame it was not able to detect. That's why it was giving this error. So now you can see it's detecting that elbow. Let's try number 4. There you go. Detecting the right elbow very nicely. Let's try number 5. There we have it. Excellent. The frame rate is amazing. So you're getting real time. Number 6. Pretty good. And the best part is it's running on CPU. It's not actually using GPU to run this. So that is very good. Then we have number 8. Let's try that. Okay, that looks good. And then we have number 9. So yeah, that is pretty good. So there are a few instances where it gets it wrong, but overall you can see it's really good. Hey everyone, welcome to my channel. In this video we are going to learn the latest face and eye detection method that runs at an amazing 60 frames per second, and all of this on an HD resolution. This is a lightweight model provided by Google, so it runs on CPU and mobile devices as well. So here we are in our PyCharm project, and the first thing we will do, we'll go to File, Settings, and we will go to our project and the interpreter, and we will add. So here we are going to add OpenCV-Python, and we will also install MediaPipe, which is the library that will help us detect the faces. Okay, so now both of them are installed, and here on the side you can see that our project is called Face Detection Project, and then we have a folder called Videos. So let's open that up and see what it contains. So here is the folder, and we have a total of 6 videos that we are going to test on. Now you could do it on a webcam as well, but I'm going to do it on a video because one, it will be more clear, and second, with the webcam you will have a limit of the frame rate. So with the videos you will have faster frame rates. Okay, so we are going to right click and we will go to Python file, and here we are going to create our project. So we will call this face detection basics. So the idea is that we are going to look at the very basics, the bare minimum code that is required to run it. And once we understand that, we are going to go ahead and create a module out of this so that we do not have to write it again and again for different projects. So the first thing we will do is to import CV2 and then import media pipe as MP. This is so that we don't have to write media pipe again and again. We can just write MP, and then we will import time. This will be to display the frame rate. So first of all, we are going to run our video. So we will write here cap is equals to cv2.video capture, and we are going to capture from within our video folder. So we will write here video slash 1.mp4. So this is the video that we will be using. And then we will write here while true, we are going to write success and image is equals to cap.read. So that will give us our frame, and then we are going to write cv2.wait key as 1, and we will also write cv2.imshow. We will write image and then image. So this is pretty much, you can say, the boilerplate of our projects that we have been doing. So we can simply right click and run this, and we have an issue cv2 dot is it, oh, it's called videos, it's not video. Okay, so there you go. So this is the video that we will be using, and as you can see, it is going pretty fast because it is running at a higher frame rate. So you could reduce the frame rate from here. For example, if I put 10, you will see that the frame rate is it's much closer to real time. But we're not going to do that. Instead, we are going to display the actual value. So to do that, we will simply write here ctime is equals to time.time, and then we will write fps is equals to 1 divided by our current time minus the previous time, and then we are going to write that our previous time is equals to the current time, and then we can display it. So we will write cv2.putText, we'll put it on our image. We are going to write fps, oh, I wrote it wrong, f and then fps, and then we will write curly bracket, and inside that we are going to write integer and then fps. And what else? Then we need to define the position. So let's say 20 and 70, and then we are going to write down the font. So cv2.font, let's take the plain one. Then we have the scale, let's put it as 3. Color, let's put it as blue or green, let's put it as blue. 255 0 and 0. Okay, then we will write, let's say, the thickness, and yeah, that's pretty much it. One more thing we have to do, we have to declare the p time for the initial frame because it is not defined before and we are using it here. So we need to define before that, and all of this needs to be before the image show. So we are going to put it down here, and we can simply run this and see what happens. There you go. So you can see the frame rate is extremely high, 140s, 160s, something like that. Blue might not be the best color, so let's put it as green. Let's try that. Yep, that's much better. Okay, so now that we have our frame rate, by the way, as I was mentioning before, you can reduce the frame rate from here. Let's say I put 20. So now you will see that, yeah, it's much closer to real time. It's around 30 something, 40. By the way, this video is a slow-mo. So that's why it looks a little bit slower, because the video itself is a slow motion video. So if I open it up and I play this, you can see this is actually a slow motion video. Okay, we could use the second one as well. Yeah, this one looks real time, or it's hard to tell. Okay, we could try it with the second one here. Let's see how that works out. Yeah, it's not real time either. Okay, so anyways, so that's the idea. So we will keep it as 1 because we are going to process it, and hopefully we are going to get a good frame rate. So you can see it's quite fast. So what is the next step? The next step is to import our MediaPipe functions or classes so that we can use them. So here what we will do is we will use the face detection module. So we will write here MP face detection is equals to MP dot solutions dot face detection. Yeah, okay. So then we need something to draw. Now we can draw ourselves as well, but we can import the drawing part here as well. Let's say MP draw is equals to MP dot solutions, and then drawing utilities. Okay, so basically this will allow us to draw without going into the details, but if we want to draw ourselves, we can do that too, because drawing a rectangle should not be that hard. But we are getting a few points as well. We will be getting 6 points, so for the eyes and the nose and the ears. So we could simply draw them by using this. Okay, then we are going to write face detection is equals to MP face detection dot face detection. So this basically initializes that we are going to use a face detection. Again, my spellings are wrong, to fix that. Okay, so then we can simply go, and this is an BGR image, so we need to convert it into RGB before we do that, before we send it to the MediaPipe library. So we will write here image RGB is equals to cv2.cvt color, and we will give in our image, and then we will write cv2.color underscore BGR to RGB Okay, so then we will write here that our results is equals to face detection dot process, and we want to process our RGB image. So this is the idea. Whatever the output is, it will be stored in the results, and then we can process these results. So we can print this out. We can write here results, and let's try it and see what happens. There you go. So now all of a sudden you have seen that the frame rate has decreased. So if I don't run this and I don't print this, you will see that the frame rate is very high, but as soon as I run it, the frame rate reduces to around 60, 70, I can even see 90s. So yeah, so it means it's working at the backend, and it is giving us a class. So they have their own class by MediaPipe Python solutions. So what we need to do is we need to know how to extract the information out of this. So we are going to do that next. So here we are going to write, so it can be multiple faces. Actually, let's go to a video. Let's go to the first video again, because it has multiple faces. So we will check if the results dot detections is available, then we are going to write for ID and then detection in results dot detections. Okay, so we are going to find in that, but it should be enumerate because we want the ID number as well. So we will write this and then we can loop through each one of the results and we can display them. So we can write here print detection. So whatever we have, it is being processed here. And what we can do is we can display it with the ID. So we can write ID and then it will show us the detection. So let's run that. Okay, there is some issue here. Where is it? Results dot, again the spellings, detections. Okay, so if I close this and if I go up here, you can see these are the key points. So here it is saying that this is detection number 1, this is ID number 1, and they have given it a label of 0. This is the score. This is 91% sure that it is a face. Then there's location data within it, which means the bounding box. And then there are key points. So 1, 2, 3, 4, 5, and 6 key points. So you can use these key points as well, but we are more interested in the face itself. So here you can see this is 0. This is face number 0. And this is face number 1. So the label ID is same because both of them are faces. And here we have face number 1 and here we have face number 0. So now we need to know how to extract this information. So we already know that this is a class. So what we can do is we can, for example, if we wanted the score, we will write detection.score. So if I write here detection.score, that will give me the value of the score. So I can print that out. What happened there? So if I print that out, you will see I'm getting the detection by itself. So separately, I'm getting the value. So I can get that. Then how can I get the, for example, the X minimum? So this is the XY position that we want. So to do that, you can see that we have, first of all, location data. Inside location data, we have relative bounding box. So we need to write that. So we will write here print. We will say location data. First of all, detection dot location data, and then we will write dot relative bounding box. So that should give us the values. So let's comment these and let's run this. And there you go. So now we simply have the information of our bounding box. Okay, so that is good. Now, what else can we do? Now, the thing is that these are, you can say, normalized values. So they are normalized between 0 and 1. So what we need to do is we need to multiply them with the width and the height to get the pixel values so we can draw. But before we actually go into the drawing, we can also draw by the function that they have provided. So that function is mpdraw dot draw landmarks or draw detection, and then we have image, and then we have the detection. So yeah, that should draw the faces for us. There you go. So now you can see we are getting the points and we are getting the faces, the bounding box around the faces. Now the thing is, for me, the points are not very accurate. I don't see them being useful. You can see sometimes maybe you will get a better result. Maybe, let's say video number 2. Let's try that. Yeah, here it's a little bit better. You can see the eyes and the nose. And let's try number 3. Yeah, here for the baby, you can see it's quite good. So again, if you want to use the points, then you should make sure that the video is quite zoomed in. The focus is on the face. So if you want that, you can use the points for the eyes and for the nose and for the ears. So the same way we got the information of the X and Y and the score, the same way you would get the information of the landmarks. But I'm not going to go into the landmarks. I will just keep on the bounding box. We will focus on the bounding box, and we will also focus on the score. So these three things are what we are interested in. If you want more, you can add on to it. So now that we know how to draw this, what we need is we need to draw ourselves. We need to get the bounding box information so that if we want to use it, just the numerical values, we should have access to those. So what we will do is, instead of using all of this, so if I wanted the value of X minimum, I would have to go inside this as well, and I will write X minimum here. Now that is a very long call for just one value. So we need to shorten it so that it is easier to work with. So what we are going to do is we are going to store all this information in a bounding box. And from that, we are going to extract these information. We are going to multiply. So what do I mean by that? Let's have a look. So we will say that our bounding box coming from the class is equals to detection, all of this, detection dot location data relative bounding box, all of that. So that is the bounding box coming from the class. That's why we wrote C in front of it. But then we are going to convert it in our own language so that we can work with pixel values rather than just the normalized values. So we will call that the simple bounding box without the C. And what we need to do is we need to write here that our bounding box C dot X minimum multiplied by our width. Now, but we don't have the width. So what we will do is we will write up here that our image height, then our image width, and our image channels is equals to image dot shape. And then I can use here I width, image width. By the way, this I here is not a big deal because defining variables is about scope. Where is it being used? If it is being used in a lot of different places, it has a very wide scope. Maybe it's being used out of the function, out of the loop. Then yes, then you need to define long names that are clear, like here, location, data, relative, bounding box, and whatnot. But if you are using it in a small scope, for example, when you use for loops, you write for I in range, right? So why did you write I? You wrote I because you're not going to use that I outside this for loop. The scope is very limited. So if you're writing IW, IH, or even WH, it's not a big deal. So then we are going to convert this into integer, and then we are going to copy this. And here we are going to write that we need the Y minimum, and we are going to multiply this with the height. So that's the idea. And then let's go to the next line. So we'll put a backslash, and then we will copy this. And here we are going to write width, and we will keep it IW, and here we will write height. So now our bounding box will have X, Y, and width and height. So we can simply use to draw this using a rectangle function, or we can use these values outside in our project. So that should be good. So what we can do is we can write here cv2.rectangle, and we will put the image, and we will say the bounding box. We can simply feed in the value because it contains all the four values. It will understand. And then we will, let's make it purple, 0255, and let's make the thickness of 2. So that should be enough. Let's remove this. So note that we are not drawing by default. So we are not using the default function to draw. We are drawing by ourselves. So let's run that. And there you go. So now we are getting a clean box, a bounding box that is quite nice. There you go. You saw here, yeah, you can see here we are getting some false detections as well. So what you can do is you can change the what do you call, there is a parameter here, minimum detection confidence. So you can change this. So you can write here, it's by default it's 0.5. You can write, let's say 0.75. Hopefully that will remove that. There you go. So now you don't see the false positives. Okay, so that is good. Now what else can we do? So this is quite good, and the only thing we might want to see is the confidence value. So the confidence value, or the score, as I mentioned, you can get by detection.score, and we can put it, let's copy this, we can put it on the bounding box, and here we can write, for example, that we have, let's keep it integer, we have detection.score, and we are going to get the first element of it. If you don't get the first element, it will just put a bracket around it. So it has only one value, but it will put a bracket around it. So we are just removing that bracket, and we can multiply it by 100 so that it is a percentage. And we can write outside that this is a percentage, and we don't need to write anything at the beginning. And the location should be bounding box at 0, BBOX at 0, and then bounding box, I think that is way too much. Okay, let's bring that down too. So bounding box at 1, but we are going to subtract -20 from it so that it is easier to see, it is not overlapping with the box. Okay, so let's run that and see if it works. There you go. So we are getting 90 something % of score, the confidence level. So I think it should be the same color, so it looks blended in. So we will put it here, 255. What else? I think the size was big too, so we can change it to 2. Yeah, that looks much better. So let's try out the first video. There you go. So that's pretty good. We are able to detect with the score and with the bounding box value. So now this is good, but the problem is that you can see that there is quite a bit of code that you have to write to find the face and to get the values that you can use. So what we can do is, instead of initializing and writing all of this code again and again for different projects, what we will do is we will create a module out of this so that we just import that module and use it whenever we want. Okay, so how can we do that? So we are going to go to Python file, and we will call this face detection module. And here we are going to copy all of our basic code. Now the first thing for the module we need is our if statement. So if we have the name underscore name is equals to main, so this means that if we are running this file, then we need to run main. So whatever is in main is like the dummy code. It is kind of a hint that this is how you can use this module. So we are going to declare here that this is main, and inside main we are going to write our while statements. So yeah, let's copy this part. We will paste it in the main. Then we have the while, so we will just read the frame, and then we have the ending part. We will put the frame rate as well over here. So yeah, that should work fine. Then we are going to, okay, so then we are going to create our class. So we are going to call this face detector, and we are going to define our initial function, initial method init, and then inside that we are going to write okay, let's leave it for now, or let's write it. Minimum detection confidence, the detection confidence. Okay, that should be fine, and we will give it a default value of 0.5. Now the thing is that we need to put everything which is related to initializations over here inside. So we will take this and we will put this in, and we will remove some spaces. First of all, we need to write here self dot minimum detection confidence is equals to minimum detection confidence. So in objects or in the classes, all we need to do is we need to write here self dot, and here we will write self dot, and self dot. So it is not a generic variable or a global variable. It is now an instant variable. So whatever we are defining is for this class or for this object. So that's why we are writing self. Okay, so that is good. Now we need to define another function or a method called find faces. And we need an image. Do we need anything else? We can put a flag of draw. So draw is equals to true by default. So we are going to put all of this in, and let's see what do we need to change. First of all, we need to write the self dot. So here we will write self dot face detection, and then we will also write self dot results. Self dot results in case we want to use it later. It's not really required at this point, but anyways, so we will comment this. We can remove all of this, and what else? Okay, so now we need to return something. So we are finding the faces, that is all good, but we need to return all these faces. So what we will do is we will return the bounding box information, the ID number, and also the score. If you want to return the landmarks, you can return that too here. So what we will do is we will create a new variable, a new list, and we will call it bounding boxes, plural. So we will make it empty, and all of this is being done for one face. So it is showing and it is processing face by face. So what we need to do is whenever it processes, we need to put that in our bounding boxes. So here, when we have our bounding box value, then we can send in whatever we want. So in this case, we are going to send bounding boxes dot append, and we are going to append first of all the bounding box, and then we are going to append the detection dot score. So if you want, you can append the ID as well, but normally it is the same. It will have the same list number, the index of the list. So it is a bit redundant, but anyways, if you want, you can add this too. So this is the idea. Then we simply return these bounding boxes. So we return bounding boxes, and we also return the image that has all these detections on it. So that is the idea. So by now we should have it running. Let's try it out. So we are going to create an object from our class. We will call it detector, and we are going to write that our face detector, and we are not going to give in any value. So by default it's 0.5. We will keep it 0.5. So once we get the frame, we are going to write here image is equals to detector dot find faces, and we will give in our image, and we will keep it the draw as default. So that is good. Now if we run this, it should pretty much run the same way as it did before. and there's an error. So inside of main, okay, so here we are facing an issue with the bracket probably. What is it? Image, this is fine. I think it seems fine to me. Let's go here and copy this. Yeah, it's exactly the same. So it should work. The error is not here. It's probably because it's not finding the image. Okay. Let's remove this part and try it. Yeah, it is about the image. It's not able to get the video. Why are you not able to get the video? Are you not able to get videos 1.mp4? Okay, let's remove this as well. Ah, okay, I get it. My bad. There are two parameters that needs to be returned, so we need to write here bounding boxes. Yeah, that was the issue. So let's run this. And there you go. No, this is the module. Yes, this is the module running. Okay, so that is good. Now it is running. And okay, it's not detecting properly. Why? Did we change the... We can change the value here. So maybe let's say 0.4, but it was working before. Yeah, here it's 0.75. That's the issue. So we need to put this here. Minimum detection, self dot minimum detection. Okay, so that is good. Now we do not need to do 0.4 here. By default it's 0.5, so it should work fine. There you go. So now it is detecting properly. Okay, so that is good. Now it is working as a module and we can get the information. By the way, you can just print here, print the bounding boxes, and let's see, what do we get? There you go. So now you're getting the information. So this is face number 0. This is the bounding box. This is the confidence. This is face number 1, bounding box, and the confidence. So you can extract this information and use it very easily. So by now we are pretty much done, but I want to do something else. Now this is, you can say, kind of a fancy thing. If you want to do this, you can add it, but it is of course not necessary. So what I want to do is, we are always showing these bounding boxes the same way. We are just drawing a rectangle and it's very plain. It doesn't look good. This is a new method, so I want to show it in a new way. So what can we do? So what I was thinking is that we can put some corner, lines, a little bit thicker. So that will give it an image of like a target. So whenever you have a target, you have these edges that are thicker, and then you have the bounding box in between, something like that. So let's try to add that here. So what I will do is, I will create a new method here, and I will call that, let's say, fancy draw. Instead of regular draw, we are going to do fancy draw. So we are going to write here that we need our image and we need the bounding box. So we will do one at a time. So just send us one bounding box and we will put the bounding box around it. then send the next one, and then so on. It will not take an array. Okay, so then first of all, we are going to open it up. We are going to extract the information from it. So we are going to write here x, y, width and height is equals to the bounding box. And then we also need the x1 and the y1, which is basically equals to the diagonal point. So x and y is the first point, or you can say the origin point, and then x1 and y1 is the bottom right point, so the corner points at the diagonal position. So rather than calculating it again, we can just define it right now. So we can write it as x plus width and y plus height. So now we have all the information we need. Now we can start drawing the lines. So here we will write cv2.line, and inside the line we need to send in our image, and then we need the starting point. So I will say the starting point is x and y. Then we have the x plus a certain value. So this is the length of that line. So let's write here length is equals to, let's say 30. We will write here length, and then we are going to give in the value of y. So y will stay the same. So then we will give it a color. The color will be the same as the what you call rectangle. So we will write here 255, 0, 255, and here we have to write the thickness. So let's write here that this is the thickness is equals to, let's say 10. So I will write here T. So it might be a little bit confusing at this point, but let me show you how it works. So let's remove this rectangle from here, and I will put this here, rectangle, and then I will write here fancy self.fancy draw, and I will give in the image and the bounding box. So that's the idea, and it will return the image. So we can write here return image, return image. Okay, so let's run this and see what happens. So there you go. So now you see there's a thick line on the corner. Now we need to draw the line at the bottom. So let's draw that. So we will copy this and we will paste it here. Now this time around, the x will be without any extra value, no length for the x. We will add the length to the y. So if we run it again, now you see we have a corner point. So we have a corner, we have two lines at the corner. So what we need to do now is we need to replicate this on the others. I think the thickness for this should be 1. We can give it, let's say rectangle thickness is equals to 1, and we can put here RT. Let's run that. Yeah, this looks much better. Okay, so, and even the thickness for this is too much. Let's put it as 7, let's say. Yeah, it's getting better, maybe 5. Yeah, that looks good. So next what we can do is we can write here that this is for the top left, which is basically for x and y. Okay, this is the point x and y. Then we will copy this and we will paste it here, and we are going to say that this is for the top right. And now our position will be x1 and y. So we will just change this to x1, and that should work fine. x1 and y, yeah. So one more thing is that if I run this now, you will see the issue. It is going outwards. We need to bring it inwards. So how do you bring it inwards? You simply subtract the length instead of adding in the x direction. So there you go. So now it's inwards and it's done. So we need to do the same for the next two. So we will copy this and we will paste here. So for the bottom left, and then we have the bottom right. So for the bottom left, we will have X and Y1. So we will just replace this with Y1 everywhere. And then this will remain positive, but this will be negative. Again, you can play with these and you can see if it gives you a problem, then you can replace it if you don't understand it directly. So this is the third one. And then for the fourth one, it will be X1 and Y1. So we will write here X1 and Y1, and the values will be both minus. So both of them will be inwards. There you go. So now it looks much better than just a rectangle drawn around it. So, and yeah, one more thing I forgot to add is the condition for drawing. So if we want to draw or not. So here I can write if draw, then we do this. Otherwise, no need. So if I run this, it will draw. If I go back here, and where is it? Here. And if I put this as false, it will give us the values, but it is not going to draw. Oh, what is that? We didn't put that in the draw. Yeah, this needs to be in the draw. There you go. There you go. So now it's not drawing anything at all. And if we go down and we write here nothing, then it will run because by default it's true. So as you can see, now we have our face detection, which is running almost at 60+ frame rate, which is pretty amazing given that we are only using a CPU. And this is an HD video, so it is 1280 by 720. If we are running even lower than this, for example 640 by 480, the frame rate will be crazy high. So you can keep that in mind. Let's try this one. It's pretty good. Let's try, how many do we have? We have 6 videos. Let's try all of them. This is number 4. It's pretty good. And you can see here, see, that's the thing with hard cascades, that it does not detect on the sides. So if you rotate your face, it will not detect at all. But this one does. So that is pretty cool. There you go. Oh, this kid is really enthusiastic. Then number 6. There you go. So even on the side, but if it's gone too far, maybe it will not detect. But here you can see it's blurry and it's on the side, and even then it is detecting quite a bit that there is a person there. So that is pretty amazing. Hey everyone, welcome to my channel. In this video we are going to learn how to detect 468 different landmarks on faces. We will use the model provided by Google that runs in real time on CPU and on mobile devices. So here we are in our PyCharm project, and we have created a new project called Face Mesh Project. Now we have a special folder here by the name videos. And if you go inside, you will see that we have a couple of videos. In fact, more than a couple. You can see here that we have a total of 8 videos. And each of these videos, they have a different size. So they are not actually the same width and height. You can see this one is smaller. So the frame rate might vary based on the size. So let's try this one. Yeah, this one is quite, I think this one is HD or even full HD probably. So yeah, so these are some of the videos that we are going to test on. So what we will do is we will right click and we will create a new Python file, and we are going to call it Face Mesh Basics. So what we will do is we will learn the basics, and once we know the basics, we are going to create a module out of it so that we don't have to write it again and again for different projects. So the first thing will be to install our libraries. We will go to File, Settings, and the Project Interpreter, and we will add the OpenCV Python, and we will also add MediaPipe, which is the library provided by Google that we will be using to detect all these different 400 plus points on the faces. So one of them is already done. The other one is also done. Great. So now we are going to import CV2, and then we are going to import MediaPipe as MP. And then we will also import time to see the frame rate. So as always, the first thing we will do, we will run our video, and we will use cap is equals to cv2.video capture, and we are going to give in our video path. So here it is in videos /1.mp4. Let's use the second one because the second one has two faces in it, so that will be better when we are testing. Okay, so then we are going to write while true, we are going to say success and image is equals to cap dot read. We are going to read our image, and then we will say cv2.imshow. We will say that it is an image img, and then cv2.wait key as 1. So that is pretty much it. So let's run it and see if it works. And there you go. So you can see the video is now running, and we have two faces. The first one, I believe, has only one. Yeah, and it is quite big. So it is, I think, HD. I mean, full HD. So let's work on number 2. And later on, once we are done, we can try number 1, number 3, 4, 5, and so on. Okay, so the next thing we will do is to write the frame rate. So here we are going to write ctime is equals to time dot time, and then we are going to write fps is equals to 1 divided by ctime minus ptime. So P stands for previous, C stands for current time. So then we will write that our previous time is equals to current time, and up here we are going to define the previous time is equals to 0. So that should give us the frame rate, and then all we need to do is we need to put it on our image. So we will write put text on the image, and we are going to write fps, and in the curly brackets we are going to write integer of fps, and yeah, that should be it. And then we have to give in the location, so 2070, and then we will give in the font cv2.font. Let's give it a plain font. And what else? Then we will give the scale, then the color we will keep it as green, and then we will give in the thickness. So yeah, that should be enough. So let's try that out, and there we have it. So now we are getting the frame rate. It is quite high at the moment. Okay, so that is pretty good. We can bring this down. Now the next step would be to use our MediaPipe library to actually find the points, the different points on the face. So what do we need? First of all, we are going to write here mpdraw is equals to mp.solutions.drawing utilities. So this will help us draw on our faces. Now we could draw ourselves as well, but the thing is that when they are using their own function, they actually make some lines in between, some connections between these points, and that is quite complicated. So rather than doing it manually, we could use their function for displaying purposes. But if you just want to see the points, you can just draw circles by yourself as well. I will show you how to do that as well. Okay, then we are going to write mp face mesh is equals to mp dot solutions dot face underscore mesh. So we will be using this to actually create our face mesh. So we will write here face mesh is equals to mp face mesh dot face mesh. I know it's quite a bit of repetition, but this is what we need to actually create our object and from where we can actually find our faces. So then inside this, if I press the control button and I click on this, it will take me to the function itself, to the class face mesh, and here it will tell me that what are the input arguments. So here we can see it's static image mode is false, then we have the total number of faces, then minimum detection confidence and the minimum tracking confidence. So the static image is whether you are using it only for detection or you are using detection and tracking. So if it is a static image mode, it will always detect in each and every single image. But if it is false, then it will detect and then it will track. So detection is always heavier than tracking. So therefore, we will detect first whenever the confidence is above 0.5, which means that it has found the probability of 50% for a face. Then we are going to detect and then we are going to keep tracking that face if the tracking confidence is higher than 50% as well. So we can change these parameters as well, but for now we are not going to do anything here. Actually, we can change the maximum number of faces because we want to detect 2 faces. So here we can write max number of faces is equals to 2. The rest we can keep it as it is. So then we are going to go down here, and this actually accepts this class actually accepts only an RGB image, so we have to convert it. So here this image is BGR, so we will convert it. So we will write image RGB is equals to cv2.cvt color, and then we will write image cv2.color underscore BGR to RGB. So that is the idea, and then we can simply write results is equals to face mesh dot process, and we are going to send in our RGB image. So that is the idea, and now what you will see is that the frame rate has dramatically reduced. There you go. So now we are getting right 50s to 60s, which is actually quite high considering that I'm only using CPU. But if we do it on the first one, it will be slower because that is a full HD video. Yeah, so it's around 40s. And if we are doing it on an HD video, then it is around 60s. So that is pretty amazing. Okay, so that is good. And now we are getting some results, but now we need to display them. So to display them, we are going to write if results dot multi-face underscore face underscore landmarks. Then if something is detected, then we are going to go ahead and draw. But the thing is that you can have multiple faces here, so you need to loop through the faces before we actually draw. So to do that, we will write here for face landmarks, let's say face landmarks, in results dot multi underscore face underscore landmarks. We are going to go ahead and loop through that, and for that we are going to now draw. We will write here mp draw dot draw landmarks, and then we are going to give in our parameters. So if we go over here, you can see that you have the image, you have the landmark list, you have the connections. So here, first of all, we will give in our image. Then we have the landmarks, which is basically your face LMS. These are the face landmarks. And then the connections. So we are going to write mp face mesh dot face connections. So let's try that out. Let's move it a little bit here. Okay, let's try that out. And there you go. So as you can see, now we are getting the faces, and both the faces are being detected. And if you go back and you write here 1, you will see that only one face is detected. There you go. And you can see how fast and accurate that is, which is pretty amazing to see. Okay, so what if you want to change the size of, let's say, the thickness of the circles or the thickness of the lines around it? So what if you want to do that? Well, to do that, you can write here some specifications. So you can write here draw, no, not mp draw specs is equals to mp draw dot drawing specifications, and there you can write that my thickness is equals to 1 and my circle radius is equals to 2. Let's say, because I'm changing right now, I think initially it is 1 1 or 2 2, something like that. So we are changing it a little bit so that we can see an effect. So once we do that, then we will go to our mp draw over here, and we are going to write our specifications here. So we will say that landmark drawing spec, I think it is the next one, so we can directly write, yeah. So these are the next 2 parameters, so we can directly write them. So we can write here that it is draw specs, and then again draw specs. So let's run that, and there you go. So now you can see it has changed, and let's say I increase the radius like dramatically. Let's put it 5. So there you go. So now you can see all these weird points, and let's say let's increase this as well to 5, and there you go. So now it is completely blocked. So anyways, you get the idea. So you can put 1 1 here. 1 1 with an HD video is fine, you know, it looks good. But if you have a full HD video, then 1 1 is way too subtle, at least to me. Like, I can't really see the points here. So if you put maybe 2 and you put here 2, then it is more visible. Yeah, something like that. So anyways, you can play around with this all day and you can see which one suits you the best. So this is basically the basic idea of how you can draw. Now that is all well and good, but in reality, when you're creating a project, you need to use these points. You need to know their positioning to actually use them in a project. So how can you get the actual points? Now there are a total of 468 points. So that's a lot, but what we can do is we can at least look at them and we can maybe number them. Maybe you don't know which one is which, so we can put the numbering over there to see which is the nose, which are the starting of the lips, starting of the eye, edge of the eye, and so on. So how do you get these values? So what we will do is, now here we are getting into one face. So face LMS is the landmarks of one face. Now in order to get further deep and find out all the different points, we are going to add another loop. So we will write here for lm in face landmarks dot landmark. We are going to get each of these landmarks and we are going to print it. So we are going to write here print lm. So if I run this now, you will see these are the landmarks. So you get the X position, your Y position, and Z position. So this is the basic idea. So now these landmarks, we are going to first convert them into pixels so that we can use them. Right now they are normalized from 0 to 1. So we are going to write here IH, IW, and IC. I stands for image, image height, image width, image channels is equals to image dot shape. So when we get the shape, now we can multiply it with the normalized values to get the actual pixel values. So what we are going to look at is the X and Y. If you want the Z as well, you can add that as well. But I'm going to write X and Y only. So to get the X and Y value, all we have to do is we have to write lm.x, and then we have to multiply it with the width. And for the height, we will write lm.y multiplied by I height. So that is the basic idea. So now we have our values in terms of pixels, and we can do whatever we want with them. So let's first of all print them out. So we will write here X and Y, and we can comment this part. So let's run that. And if we go back, you can see these are the points that we are getting. So if we want to get the ID for it, well, we can put it in a list and we can check the index of that list. But if you just want to look at it, you can write here enumerate, and here you can write ID, and what you can do is you can write here ID. So that will give you the ID number, and then it will tell you the actual value. So here you can see it starts at, where does it start? Okay, it starts here at 0, and then all the way it goes till 467. So we have a total of 468 values, and each value has an X and a Y point. So a Y, X and a Y number. So here what we will do is we will put this in a list. So what we can do, or let's keep it till here, and then now what we can do is we can create this into a module, and in the module we are going to put it in a list and we will return something. So let's keep the basics still here, that we are getting the numbers and everything, and yeah, that should be good. So let's run it for 2 faces, and let's run it with video number 2. There you go. So if we go down here, you will see a lot of values being generated. That's good. We could also add an enumerate here, and we could write which face number are we talking about, face number 1 or face number 2. But let's forget that, and let's go ahead and do the, what do you call, module. So the idea of the module is that once you create the module, you don't have to write all of this initializations and all of this conversions again and again. So all you need to do is you need to call that function or that method within our class, and that will do the magic for you, and it will return you the values, and you will be happy to work with it. So how do we do that? We right click, we go to new, we create a Python file, we call it face mesh module. Okay. So what we will do is we will go ahead and copy all of our code, and now we are going to convert this into a module. So for the module, the first thing we have to do is we have to write what to do if you are running the module by itself. So we will write here if __ name is equals to __ main, then we are going to run our main function, and we will define our main function here, main, and we will write down our loop inside it. So we will copy this part, actually we will cut it, and we will paste it here, and then we will go here and we will cut this, and we will paste it here. And what else? We will cut this and we will place it above the while. So that gives us the initial part. So if we were to comment all of this and if we were to run this, it should run. So let's try that. There you go. So this is like we are starting from the scratch. Okay, so then we are going to convert it into a class. So here we are going to write class is equals to face mesh detector. You can write a better name probably, but we are going to use face mesh detector, and then we are going to define our initial method for initialization, and we are going to give in some parameters. Now these parameters will be the ones that are where is it? This one. So for the face mesh, so whatever parameters we have here, we are going to give in to our object. So let me write down here. So we have static image mode. So we will write here static mode is equals to false. So this will be by default false. And then max faces is equals to 2 by default. Then minimum detection confidence is equals to 0.5, and then minimum track confidence is equals to 0.5. So we are going to write these, and then we have to tell that these are the values of this instance. So we will copy this twice, then we will copy this again, we will copy this again, and we will copy this again. So here we will put equals to, equals to, equals to, and equals to, and here we will write self dot this. So we will copy that, self dot, self dot, self dot. So if you're not familiar with this, I would highly recommend that you check out object-oriented programming, the basics of object-oriented programming. So then we are going to uncomment this, and we are going to write self in front of each of these, and then we are going to write self here as well. And here in the max number of faces and all of this, we need to write our new variables. So here we have self.static mode, self.faces, then minimum detection, let's write it in a new line, and then minimum tracking. So that is the idea. So that is good for initializations. This, if you want to make it a parameter here as well, feel free to do that. I think it should be fine without it. Okay, so next we are going to write a function called, or a method called find mesh face or faces. I don't know, find face mesh, let's say face mesh. And then we will write, of course, self, and then why is it not okay? The indentation is wrong. It should be here. Okay, so then we are going to write image and draw. So we will have an option to draw or not draw. So it will be a flag. So we can uncomment this, and we can go back up here, and then we will see what is missing. So this indentation is wrong, so we need to go back. Okay, so then we will just copy this self dot, and again we will start putting the self dot everywhere, and self dot results, self dot mpdraw, wherever it's giving an error, just put a self dot. Okay, so that is good. And wait, what happened here? Need to go back. Okay, So that is good, and now we should be able to see our results without going into the returning part. We should be able to see the result, but we didn't create an object, or we didn't call the find face, so it will not do anything. So we need to do that. We will write here detector is equals to face mesh detector, and then here we are going to write here that our image is equals to detector dot face mesh, or is it find face mesh? Yeah, find face mesh, and we will give in our image, and we will keep it true for the drawing part. And here we are going to return our image, so we will write here return image. So that should be good, and let's see if it works. There you go. So now it's working as an object, but the last thing we have to do is we have to convert this so that we are getting our values in return. So that's the main thing. So, and again, the drawing part again is optional, so we can directly put here if draw, then do this. So if I run this now, it should draw. If I go down here and I write here false, it should not draw. It will work, but it will not draw anything. So that's good. Okay, so what is next? Yeah, so now we need to uncomment this, and for every face we are going to go through every landmark, and through every landmark we are going to convert it into X and Y, and then we need to store it. So where do we store it? We store it in, let's say, a variable called face. So this will be a list, so we will store it in list face.append, and we are going to append the X and Y. So this will be the X and Y value. Now that is good for one face, but we have multiple faces. So what do? We create another list. We call it faces, plural. And this time around, we append, after the loop, we append faces.append face. So basically, when we are looking for the landmarks, we append the landmarks in the faces, and then once we have that face with all the landmarks, then we append the faces so that we get the final result. So that is the basic idea. Actually, let's put it outside so it doesn't give a random error that it has been used before declaration. So yeah. So in any case, we are going to return faces. So even if it's empty, it doesn't matter. We are going to return it. So that's the idea. And then in the image here, I can write here faces, and that should return the faces. What we can do, we can print here. So we can write here if the, how can we write this? The length of faces. But if we write the length of faces, it will be, yeah, it will be something. Okay, yeah, that should work. If the length of faces is not equals to 0, then we are going to print the length of faces, let's say. So let's see how many faces do we get. Okay, we are printing a lot of things. That's why we are not having a clearer picture. So yeah, let's run it again. There you go. So now it is showing one face. And why is it showing one face? Because we put maximum 2 faces. Why is it showing 1? That is weird. Max faces is 2. Did we say something here? Are we running the module? Yeah, we are running the module. Still saying 1. Okay, Let's see, why does it say 1? So it should be 4. Oh, this should be inside the loop. My bad. So now it should work. There you go. So now you have 2 faces being detected. And if we go to video number 1, where is that? Video number 1, then it will be 1 face. So you can see here, it's only 1 face. So that is the idea. And then what we can do is to check whether we are on the correct path or not. We can write here faces at 0. Let's see, what does it print? So, oh, actually it's printing the length. Yeah, actually it's good to see that it has 468 points. So that means we are getting all the points. That is good. But now let's print all the points. It will be a long list. There you go. So now you can see these are all the different points that we have. So this is quite good. Okay, so one more thing we can do. Now, if you're not familiar with which point is which number, then what you can do is you can print the ID number over here. So you can write that CV2, actually we wrote it somewhere. Yeah, why write it again if we have it already? We can write here that CV2.putText, and we are going to put the text of our ID. So let's just write here string ID. And where do we need to put it? We need to put it at X and Y. So this is the X and Y position. 3 is way too big, so we are going to put it as 1, 1. Let's see how that works out. So this is going to print out the ID number of each of the points. Oh boy. Okay, so it's like a matrix. Okay, so that is bad. Maybe we need to look at a video that is more focused on the face, doesn't have a lot of other stuff. Let's see. Maybe this one. Maybe this one will be better. Let's try that. It is number 6. There you go. So now it's much better. So still not that good. We first of all, let's change the maximum to max faces is equals to 1. So we only look at 1 face. And then let's put this as 0.5. Okay, it's going to the kid. I was hoping it will attach to the elderly person, but no, it did not happen. Okay, let's keep the maximum faces as 2. And let's make this even smaller, 0.3. Let's try that. No, that's not readable. 0.5 is, let's try that again. Okay, so I can see 1 is here, 4, 5, then it goes to 195, 151, 9, 8. So yeah, it's a little bit harder to read still. 1.7. Yeah, now it's a little bit better. Here at the edges, you can see very clearly what are the point numbers. So 21, 54, 103, 67, and so on. But in the middle area, especially with the nose, I think I can see 1 here. So 1 is the nose, the center of the nose. Let's try another video. Hopefully we will get something better. So number, by the way, you can read all of this in the paper. So if you go to MediaPipe website, they have a paper listed there, and if you go in the paper, you will find these. You'll find more information on these points. So yeah, no, it's hard to see with this. Maybe if you have just an image and you apply this method on the image, and then you scale it up to see the numbers, maybe that will work. So anyways, this is the basic idea of how you can detect 468 points on a face and that running on a CPU. All of this running only on a CPU. So that is a pretty amazing task, and the results are pretty good. You can see, let's try out different videos. So we have video number 1. You can see it is pretty good. Video number 2. Actually, let's remove this part. Let's remove the ID, and let's keep it normal. Yeah. So let's try it again. Wait, what happened there? Oh yeah, the draw is false, so we need to remove that. There you go. That is pretty good. You can see it is very smooth. It is very smooth. Yeah. Then let's try number 3. There you go. Even when the faces are a bit far, it is detecting quite well. Number 4, that is good. Okay, when it goes to the side, it disappears. That is understandable. Then let's try number 5. This seems like a Zoom meeting. Yeah. Could be used in that. With the frame rate we are getting, it could be used in a Zoom meeting. Okay, let's try number 6. There you go. It's flickering a little bit here. Maybe because they're merging the faces at some point. Yeah, probably because of that. Then let's try number 7. How many do we have? 8? Yes. Okay. That's good. Okay, when she goes down, then of course it will not detect, but as soon as she gets back up, the face is detected. There you go. The person is laughing, and you can see that that is pretty good. Okay, so this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up, and don't forget to subscribe and share it with your friends, and I will see you in the next one. Hey everyone, welcome to my channel. In this video, we are going to learn how to use gesture control to change the volume of a computer. We will first look into hand tracking, and then we will use the hand landmarks to find the gesture of our hand to change the volume. This project is module based, which means we will be using a previously created hand module which makes the hand tracking very easy. So here we are in our PyCharm project. This is the same one that we used in the previous video. So in the previous video, we learned about hand tracking minimum code, the bare minimum code that is required to run hand tracking. And then we created a module out of this so that we don't have to write it again and again. We can simply import this module and run it as it is. Now, if you haven't checked this video, I highly recommend that you go and check that video out first, and then you can come back here and we will continue with the hand tracking project. So the project that we are working on is the, let's call it volume control, or let's call it volume hand control. So we are going to control the volume of our computer with our hand. So that is something very interesting. Now the first thing is that we will go to file and we will go to settings. We will make sure that our libraries or packages are installed. So we will write here OpenCV Python. So this is the first one that we need. We will hit install, and then I've already done it. That's why I'm not doing it. Then we are going to write media pipe, and we will click on that and we will hit install. So these are the two main libraries that we need for now, and later on we can check what we need afterwards. The first thing you have to do is you have to import your packages. So we will write here import cv2, then we will import time, and then we have to import numpy as np. So these are the basic packages that we will be using. Later on we will add some more as well. So the first thing we want to do is we want to check if the webcam is working and everything is running fine. So we will write here that cap is equals to video capture cv2.video capture, and we will write the ID number. So I'm using ID 1. Most probably you will need ID 0. Then we will write while true. We are going to check the success of the capture, and then we will write image, and then we will write cap dot read. So this is the main idea, and then we will write cv2.imshow. We will write the image and then img, and then we will write cv2 dot wait key as 1. So that will give it a 1 millisecond delay. So this is looking good. Let's run it and see what happens. There you go. So this is my hand that we will be tracking, and we will change the volume from, and this is our webcam. So what can we do? Okay, one more thing we can do here is we can write here, let's say this is the part where we have our parameters. So we can write here that our cam width, let's write width of our camera, and the height of our camera is equals to 640 by 480. So we are basically defining it here, and then we can use it here. We can say cap.set prop ID number 3 is width. So we will write width cam, and then prop ID at number 4 is height cam. So we can write height cam. So that should be good. And let's try it with the different value, 1280 by 720. So this will make it a little bit bigger. Yeah, there you go. So, but we are going to use 640 by 480 instead. Okay, so that is good. What else can we do? We can add the frame rate. So here we are going to write that our current time is equals to time.time, and then we have the FPS is equals to 1 divided by our current time minus the previous time, and then previous time is equals to current time. So we can define the previous time as 0 over here. And what else? So now we can put this FPS on our image. So we can write here cv2 dot put text, and we will write image, and then we will write FPS, and we will write the value of the FPS, let's say integer FPS, because it's decimal, we don't want decimal places. And then we can write the location 70, and then we write the font. So we can put any font that we want, and then we will write the scale and the color. So let's write 2550255, and then we will write the thickness. So that should be good. So let's run this and see if it works. Oh, it does work, but looks really bad. Okay, so first of all, the color is bad, so let's change it to blue. So we can remove this, and then let's try the blue color first. Yeah, the blue color is much better. Then we can make it smaller. It's really big. So scale, let's put it as 1. Yeah, that seems good. Thickness is fine. I think it's fine. We can reduce a little bit, but, and then we can push it up a little bit. Let's say 50. Yeah, now it really looks good and in the correct place. Okay, so now that we are all set, now we will do the magic part. The magic part here is that we already have our hand tracking module, so we don't have to write a lot of code. We will just use its functionality. and we will be able to get our hand very quickly, the landmarks of our hand very quickly. So we will write here import hand tracking module. Now, if you don't see hand tracking module, that is because you need to put it in the same folder as your project. So if it's not in the same folder, or if it's not even here, then you will not be able to use it. So you need to make sure it is in the same folder. And we can import it as something else, HTM, let's say, hand tracking module, because we don't want to write that complete name. It's quite big. Okay, so then we will create an object. So this is a class. Inside here, we have a class. Where is it? Here, hand detector. So we will create an object from it. We will call it detector. Detector is equals to, what was the name? HTM dot hand detector. And then we have our default parameters already here. So we don't need to write anything for now. So we will keep it like that. And then what else can we do? Then after doing this, we need to find the location, or we need to find the hand. So we will write here that detector dot find hands. So this is the method that we created. So this is this method, find hands. And all we need to do is we need to send in the image. So this will give us the hands. So we want to draw it, so we will not put it as false. We will keep the draw as true, and it gives us the image back. So we will accept that image back again. So that is pretty much it. So we can separate this code, not too much. We can separate this code so that it is easier to read. So now we can run it and see if it works. And there you go. So now we are getting good detection, and it seems quite good. So what happens sometimes, you can see it detects a little bit on the side, and then it detects small hand as well. So what we want to do is we want to change the detection confidence here. So at default, it is 0.5. So the detection confidence is 0.5. We want it to be really sure that it is a hand, and then only detect the hand. This way, when you are changing the volume, it will be a little bit smoother because it will not flicker too much. So we can write here detection confidence is, let's say, 0.7. So you can play around with this value if you want, but I will keep it at 0.7. Yeah, seems fine to me. And then we are going to go to the next part, which is the best part of getting the position. So now all we have to do to get this position is to write that our landmark list is equals to detector dot find position, and then we just send in our image. That's it. And we will also write draw is equals to false. We don't want to draw it because we are already drawing it. So we will keep that as false. And now let's run it. And there you go. We are getting it, but I forgot to print. So print LM list. So let's run that. And there you go. So at the bottom, you can see that we are getting that list. So here we are getting that list. And we have a total of 20 values here. 21 values, because we are counting 0 as well. So we have a total of 21 values. Now, if we want to get the value of a particular point, then we can write that point itself. So here, for example, we need point number 2. So this is the landmark number 2. So if we run that again, okay, so this is a good point. We are getting an error because the index is out of range. So before we actually print, or before we actually do anything related to the points, we have to make sure that there are some points. So we will write here, if LM list, the length of it is not equals to 0, not equals to 0, then we are going to do this. Otherwise, it will skip it. So let's try that. And there you go. So now I'm only getting landmark number 2. So this is good. But how do we know which landmark do we need? So here is the MediaPipe website, and they have given us the landmark model information. So these are all the values that we get, all the landmarks that we get. So here we will need the value number 4, which is for our thumb, and we will need the value number 8, which will be for our index. So we need the tip of both the thumb and the index. So we will go back here, and here I can write I need the value number 4, and I need the landmark list, I need the value number 8. So this way we will get only these two values. There you go. So now I have these values, and you can see they are changing. But to make sure that we are using the correct ones, we are going to create a circle around them. So we will write here cv2.circle, and in the circle we are going to say that we want to put it on our image, and then we have to give in the center value. Now here what we can do is we can create some variables so that we don't have to write all of this again and again. So we can write here x1 and y1 is equals to lmlist at number 4, and we need the first element of it. So this is the ID number 0, then this is number 1 element, which is the x, and this is the second element, which is the y. So we need the first element as x, and then we need the second element as y. And then we can copy this, and we can do it for the index as well. So we will write here, this is 8, and this one is 8 as well. So now I can simply write x1 and x2, x1 and y1. And then we are going to write the radius, let's say 15, and then we will give in the color, let's say 255, 0, and then 255, and then we will write cv2.filled. Okay, so we can copy this for the other one, and we can paste it here, and we can write x2 and y2. So this will create two circles at that point. So if we are getting the correct points, then it should draw on the thumb and the index. And there you go. So now you can see that it is drawing on the thumb and the index. So this is good. Now the next thing we can do is we can create a line between them. So we can write here cv2.line, and within the line we will give in our image, and then we will give in x1 and y1, and then we will give in x2 and y2, and then we will give in, what else do we have? We have the color, so 255, 0, 255, and then we have the thickness. So let's try that out. There you go. So now we are getting the line as well in between. Okay, so next thing what we have to do is we have to get the center of this line. So we can do that simply by writing here cx and cy is equals to x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So we can simply write it like this, and this will give us the cx and cy, and we can put a circle for that as well. So let's write here cx, and let's write here cy. So let's try that out, and there you go. So now we are getting a nice circle in between. So this is good. Now, next thing we can do is to find the length. So this is the most important thing. We need to know what is the length between these 2 points, or what is the length of this line. When we know the length of this line, then we can change the volume based on that. So what we can do is we can write our own function, and we can do a little bit of maths to square it and then square root. But instead, we are going to import math, and within math we have the hypotenuse function, so we will use that. So we will write here that our length is equals to math dot hypotenuse, and then inside that we are going to write x2 minus x1 and then y2 minus y1. So that will give us our length. So we can print it out. So let's try that. I think we are printing something else as well, so we need to remove that first. Okay, let's try it. Okay, so here you can see that when I increase the distance, the value increases. When I decrease it, the value decreases. So the maximum you can say is around 300 something. So we can say, let's say it's 300, and the minimum, let's say, is 50. Okay, so this is the maximum and minimum that we have. So one thing we can do is we can write here that if our length is less than 50, then we want to change the color of our center circle. So let's make it green. So this will give it like a button effect. So when you're pressing it, it changes. So here, let's let it load. Okay, so here when we come closer, there you go. So now it actually feels like a button, and it is very soothing. I don't know why, but it's pretty cool. And it's quite fast, so it is good. So this is good, and now what we can do is we can change the volume based on this length. So how can we do that? Well, we have a couple of libraries that can help us with this. The one that I found was PyCo. I don't know why it says Co, but it is developed by Andriy Miras. So thanks to him for developing this awesome library, which allows us to change the volume of our computer. So it is under the MIT license. And if you go down, you have to just write pip install PyCo, and then you can use this code as the template. So I will copy this because I'm lazy, and I will paste it here. Okay, so now what we have to do is we have to simply go to File, Settings, and we will add PyCo. You can do pip install as well. It's the same thing. So we can click on PyCo and we can click on install. So that is installed and we're good to go. If we go back, you will see all the errors are gone. So we will copy the imports and we will cut them and we will paste it at the top. And the rest of it, we are going to see what do we need and what we don't. So what we can see here is that we have the volume get mute. So this seems like the initializations. So we are not going to change anything there. Then here we have volume.getMute. We don't want that. Then we have get master volume level. Do we need? I don't think we need that. We might need the volume range. And then we have volume.master volume. So we can set the volume. So before we set it, let's see what is the range. So I can print this. And there you go. So our range is from -65 to 0. So this is our range. So we are going to use these two parameters. So 0 will be maximum and 65 will be minimum. We will ignore this value. So if I set the volume as -20, let's run it and see what happens. So right now it is at 26. The volume goes to 26. If I set it as, let's say, -5, let's see what happens to the volume. It goes to 72. And if I put it as 0, then you can see it goes to 100. So this is basically the idea. So what we can do is we can get the minimum and maximum range. So we can write here that our volume range is equals to volume, get volume range, and then we will say that, or we will keep it like this. Let's keep it like this. We can take the values later on. Or I think it's better to write. So we'll write here minimum volume is equals to volume range at 1, was it? Yeah, at 0. And then maximum volume is at 1. So this is our range. Okay, so now we can use minimum volume and maximum volume instead of using this. Okay, so what is the next thing that we need to do? Now the next thing is we need to convert our volume ranges. So as you saw that our minimum and maximum was 350. So we were getting, let's write it after the length. So here we know that our hand range was from 300 was the maximum and the minimum was 50. So it was from 50 to 300. Now we need to convert it to our volume range. So our volume range is from -65 to 0. So we need to convert this range into this range. So in order to do that, we have a very simple function in NumPy. So we have, did we include? Yes, we included NumPy. So in NumPy, we can write here volume is equals to numpy dot interp, and inside that we are going to give in the value that we want to convert. So we want to convert the length, and now we have to give in the range. So our range was 50 to 300, and then now we have to give in the range to which we want to convert. So our range here is the minimum volume, and this will be the maximum volume. So let's print this out. So let's print the volume. So let's remove that and let's see if this works. So right now it's -25. If I go down, it goes to -65. So here our volume is 0, and if I go up, you can see it should go till 0. Yeah, there you go. This is the maximum, so this is good. If you are a little bit confused, you can write the length here as well. So the length and the volume you can see side by side. We can make it, let's make it integer. That doesn't give weird values. So yeah, here you can see when we have the minimum volume, then it gives us -65, and then when the length is maximum, it gives us 0. So this is exactly what we wanted. So now that we have converted this, we can simply send it to our master volume. So we have the function here, we can actually remove it from here, and we can go down, and after the volume we can paste it here. So set master volume level, we are going to set it as our volume. So let's try this. So I will open up my volume and let's try this. There you go. So if I go to 0, it goes to 0 as well. If I increase the length, you can see, and now it goes to the maximum. I think 300 is a little too far. No, it's fine. You can see I can change the volume from here. You can make it a little more smoother as well by changing the range of these two over here. And even this you can play around with, because I can see it's not very proportional. So you can play around with those values to make some changes. Now, the last thing we can do is we can show the volume bar on the side so that it looks a little bit nice to see what is the volume at any given point. So what we can do here is that we can create a rectangle. So we will go down and we will write here cv2.rectangle, and we will put it on our image. We will give it the initial position, and then we will give it the ending position. So we will give that, and then we will give in the color. So let's make it green, and then we will write cv2.filled. So this is the idea. So the width of our bar is basically 85 minus 50, which is 35. So if we run this, there you go. So this is our bar. And what we have to do is we have to remove the fill. We don't want a fill. We want, let's say, 3. So let's run that. Yeah. So there is our bar. And then the next part will be filled. So the next part here, we will copy this, and now we will give in the volume. So we will say that our width is the same, but the height will be different. So we will write here integer our height. So volume of this. And do we need to change anything else? Not really. So here we need to change cv2.filled. So if we run this, volume is not defined. Oh yeah, volume is not defined here. So we can write here volume is equals to 0. Okay, there you go. So now you can see that it's going out of the image. So if I try to change, let's try to change. Does it change? No, because it is too big for us. So what we need to do is we need to convert our range again. So in this instance, our range is from, let's say, 400. So 400, let me show you here. So 400 is at this point. So this is the height 400. So when our volume is 0, it should be 400. And at this point, we have, what do we have? We have 150. When the volume is maximum, it should be 150. So our new range, so we can write here that this is volume for the bar. So we will write here, it's again 50 from 300 till 300, but the minimum now is 400 and the maximum is 150. So instead of volume, we will send in volume bar. So let's run that. Okay, now volume bar is not defined. So we need to write here volume bar. And let's do volume as well. Volume is equals to 0. Okay, let's run it. Still the same. Why? Where did I make a mistake? Volume bar is from... So where is the issue? Let's run it again and see. If I put my hand in. Okay. So the first value is wrong. So we need to go up here, and volume bar should be 400. So it is at the first point, it should be 0. So our 0 is at 400. So there you go. So now if I bring in my hand, and now if I change, you can see it changes the value. There you go. So the last thing we can do is to add a percentage at the bottom. So we can copy this and we can paste it here. And in the text, we are going to give in our percentage, but again, we don't have any percentage. So we can create another conversion here. We can write here volume percentage is equals to 50 to 300. And now it will be from 0 to 100. So we need the percentage of that. And then we can write here that our volume, this is our volume. Should we write volume, or let's just keep it like this? And then we can write here volume percentage, and then we can write percentage in front of that. But the location, let's put it for 40. Let's keep it at 40, and then let's put this as 450, and let's keep the rest same, or let's change the color. Let's make it green so it matches that. So let's try that out. Okay, volume percentage. I always forget this. Volume percentage is not defined. You need to define it as 0. Or should it be 0? Yeah, it should be 0. Okay, so 0%, 64. It's hard to see this color. Let's change the color completely. So let's keep it as blue. So I will copy the blue color. Where is it? From the FPS. And we will put it for all of these. Okay, let's try it again. Yeah, now it's much clearer. So here we can see. So 100 is a little bit hard to reach. So instead of 300, I can make it 250, for example, 275. But now you can see the percentage is changing. Let me show the volume bar. And you can see here that the percentage is changing. Hey everyone, welcome to my channel. In this video, we are going to learn how to count fingers. We will first look into hand tracking, and then we will use the hand landmarks to count the fingers. And all of this will be happening in real time, and it requires close to no installations and configurations. So here we are in our PyCharm project, and you can see that this is the same project that we used in our previous two videos. In the first video, we looked at the bare minimum code that is required to do the hand tracking part. And once that was done, we created that into a module so that we do not have to write the code again and again, and it will be easy for us to create new projects. So this will be one of those examples where we create a project out of this module. Another example that we did earlier was the volume hand control. And you can see here that this was the code that we did earlier. So all of this is available on my website. And now what we will do, also there is another folder here. You can see that it says finger images. So basically what this is, that we have the images of different fingers. So when it is 1, when it is 2, 3, 4, 5, and when it is 0. So we can have very specific ones as well, where you have the index and the pinky finger up. So then you can have only the thumb up, and you can have all sorts of different scenarios. But for simplicity, we are just going to use these 6 scenarios. But if you want to add more later on, you can do that. and it will pretty much use the same code and you can keep adding onto it. Okay, so once we are in our project, we will go to File, Settings, and we will make sure that everything is installed. Now, because this is the same project, I know that the packages are already installed, but if somebody is doing this for the first time, then I will show you what you have to do. So here you will write opencv-python and you will install this, and then you will go to media pipe, and then you will install this. So both of these are installed, so we don't have to worry about that. And then we will go to our project, we will create a new file, and this time around we are going to call it finger counting projects, let's say. So the first thing we will do is to import our CV2, the OpenCV library. Then we will import time, and do we need anything else? We will also import OS. So I will tell you why we need OS later on. Now the first thing, as always, we will turn on our webcam. So here we will write cap is equals to cv2.video capture, and we are going to give in device number 1. Most probably for you it will be device number 0. And then you have the option of giving the size. So you can write, for example, cap.set, and here we are going to write that this is number 3. Number 3 is for the width, so I can write the width of the cam, and then I can write cap.set and the height of the cam. So we need to define the width and height. So the width of the cam and the height of the camera is equals to 640 by 480. So we can write it like this. And what else? So then we have to write our while loop. So while true, then we are going to write here success and image is equals to cv2 dot cap dot read. So it will read our frame. Then we write cv2 dot imshow, and inside that we write image and then img, and at the end of the day we have to give it a delay. So cv2 dot wait key as 1. So this will give it a 1 millisecond delay so that we can see our images. Okay, so what else? Okay, the spellings here are wrong. Success. Okay, so let's try this out and see if we are on the right track. So this is my webcam and you can see my hand, and that seems good. Okay, so next we are going to do something new here, and that will be to import our images. So we have all these images. So what we need to do is we need to get them one by one, and then we want to store them so that later on, whenever we have the certain amount of fingers shown, then we can display that image. So we need to store them first. So how do you store it? You will use OS. So what we can do is we can write here that, let's say our list, my list is equals to os.list directory. So we want to list the directory. We want to list all the files that are present in finger images. So we will say that our folder path is equals to finger images. So I will copy this and I will paste it here. So now if we print this out, you will see that we get a complete list. There you go. So we get all the names. So one thing to note here is that I have put them in order, and the last one is 0. So when there are no fingers, then it will be 0 here. Now you might say, why didn't you put it here in the beginning? And there is a reason why, and I will show you later on why this is the reason. What is the reason? So then we are going to create a list of images. So we can say list of images, or we can say, let's say overlay because we want to overlay this image on our main image. So we will say overlay list is equals to empty. And now we can loop through our list. So we can say that for image path in our list, we want to import our image. So we will write here image is equals to cv2.imread, and then we have to give in the path of the image. So this is the path of the image. So it is in finger images and it is 1.jpg. So 1.jpg is basically this im path, and then our folder path is basically finger images. So we can write here f, and then we can write here folder path. Okay, f needs to be small, folder path, and then we can write slash, and then we can write our image path. So we can write here image path, im path. Okay, so now if you're confused, let me show you what this will look like. So you can go here and we can print this, and we can skip the import, or we can import, doesn't really matter. So there you go. So for each of the images, you get this finger images at 1.jpg, then finger images 2.jpg, and so on. So this way we get all the paths and we can simply import. Now we have imported it. Okay, let's keep it there. We have imported it, but we didn't save it. So we need to save it in our list. So we will say overlay list.append, and we want to append our image. So that will give us our image list. Now to confirm that everything is working fine, we can write here length of our overlay list, and we can write here print. So if that list is 6, then we should be good to go. And there you go. So the value is 6. So this means we have imported all these images and we are good to go. So how exactly do we overlay an image? Now the thing is that image itself is a matrix. So what we can do is we can define that our new image we want to put in our old image based on this location. So what we can say is that our image is equals to, so if I wanted the element, the first element of this list, I would say overlay list 1 or overlay list 0, right? So the same way, if I want to target a specific region of my image, then I can write that target space in this bracket. So this is also called slicing. So what we will do is we will give in the height first, the range of the height, and then we will give the range of the width. So we will say that I want to put my image, this overlay image, whatever it is, let's say we are using overlay list at number 0. So we are using the first image. So I want to put that at 0. Wait, what happens? I think insert is pressed, or yeah. Okay, 0 and then 200. This is the limit of my height, and then 0 to 200. This is the limit of my width. So now the reason I'm putting 200 is because these images are 200. So the size of this image is basically 200 by 200. So we can automate that. I will show you how to do that too. So let's try this and see if it works. So I will run this, and there you go. So now you can see the image number 1 is displayed at 200 by 200. So this is 0, 0, and this is 200, 200. So our image is now displayed properly. If I wanted to shift this, I can write, for example, 100 here and then 100 here. So we are getting an error that we have 100 and 200. Okay, so the problem is that the image is of size 200 by 200, and they are saying that you cannot convert it to 100 by 100. So here, if I'm increasing 100 here, I need to increase 100 here as well, so that it maintains that 200 size. So if we run this now, then you can see that the image has shifted down, So this is how you can place your image within our original image. So here we are going to write 0 and 200 and 0 and 200. But now we want to automate this. So let's say you don't have a 200 by 200 image, you have something else. The size of the image is something else, and even the size of each image could be different. So what can we do then? What we can do is we can write here that, for example, we are using overlay list 0. Okay, so we will write here overlay list 0 dot shape. So this will give us that shape, and we can store it in height, width, and channel, because we have these three things. And then we can replace this with height, and we can replace this with width. So if we run this now, then it will give us the same effect, because we don't have to worry about the size of the image. It will put it on the corner. So this is good. Now we understand how to overlay our finger image on the original image. Now what we can do is we can display the frame rate. So here we can write current time is equals to time dot time, and then we have to write FPS is equals to 1 divided by current time minus the previous time, and the previous time we have to declare up. Here we will put it as 0, and then we will say that our previous time is equals to the current time. So this will update every loop, and then we can simply write cv2 dot put text. We will write in our image, and then we will write the FPS as an integer, and we will write here FPS. And what else? Then we will write the the location. So we can put 470, and then we will write cv2 dot font any of these, and then we will have the scale, and then the color, and then the thickness. So let's try this out and see if we get a good image. Whoa, that is really big. So let's change this to font plain. There you go. So now it is quite good, and we can see that it is working. So that is good. So the next thing would be to actually go into our hand tracking part. So here we are going to go up, and we will import our module, which is the hand tracking module, and we will import it as HM. So this is what we will do, or let's say HTM, hand tracking module. And then we will create, not here, we will go down, and here we are going to create a detector. So we will write here detector is equals to HTM dot hand detector, and we will not give it any values, or should we? We can give it the detection confidence, so we can keep it a little bit higher, so 0.75, let's say. Later on, if we get some errors, we can change that too. So that is good. So here we are going to write that we want our detector to find the hands, and we will send in our image, and we will just ask it to return our image. So if we go to the hand tracking module, you will remember that this is our class, hand detector class. Inside that we have a method called find hands, and it just needs an image, and it will output the image with the drawing. So we can write here image, we will return image back, and if we print this, it should draw our hand. So there you go. So we have our hand, and it is drawing nicely. So that should be good. And then what we can do is we can create a list of the landmarks that we detect. So we will say that detector dot find position, and we want it to find the position within our image, and we want to draw as false because we are already drawing, so we don't want to draw again. So we will write here that drawing is false, and then we can print our LM list to see if we are getting something. So right now it's empty, and when I bring in my hand, you can see that the list fills up. So that is good. And now what we can do is we can write here that if the length of our LM list is not equals to 0, then we are going to do something. So that something could be anything. So what we are trying to do is that we are trying to get the tip of our fingers, and based on that tip we can decide whether our fingers are open or closed. So here is the website of MediaPipe, and we can see that these are our landmarks. So what we have to do is we have to first of all get all these points. So we need point number 4, point number 8, 12, 16 and 20. So we need to use these, and then we need to check whether these are below, let's say, number 6 or number 7. I think it's better to take number 6. You can even use number 5, but I think number 5 will be too much. So you can say that if number 8 is below number 6, then it is closed. Then the finger is closed. And if it is above 6, then the finger is open. So what we can do is we can pick one of these and we can try it out, and then we can apply it to the rest of them. So let's say we pick our index finger. So this is 8 and 6. So what we will do is we will write here that if the LM list at number 8, we will get the value of the y, not the x. So y is the third element, so it will be 0, 1 and 2. So we will write here 2. So if the point number 8 is less than the point number 6, then it means it is open. So in that case, we will write here print index finger open. So because we are using the OpenCV orientation, so up means lower values. So our image is starting from the top, so the maximum value at the maximum height is 0. So to check, for example, here our value is 50 and here our value is 100, then it means our finger is open. If it's the opposite, if it's 100 here and then 50 here, then it means it is closed. So here we are going to try out and see if it says finger open. So here right now it's saying finger open. If I close it, you will see that it stops saying. Actually, let me remove the print. It's quite annoying. So let's run it again. So right now it will say index finger open. If I stop, if I close, then it will stop. And if I open it again, it will say index finger open. So this is how you can tell if the finger is open or not. So now we need the tip points for each one of these. So for each finger, we need a point. Now we could write a lot of if statements. And if you are using a lot of different types, for example, if you have the pinky finger and the index one up as well, and then you consider that a different gesture than your two fingers of any kind, for example, the index finger and the middle finger up. So if you want to differentiate between these, then you have to create lots of different images, lots of different scenarios. But here we are only going to use 6 scenarios, so we can simply use a for loop. So what we will do is we will create a list here and we will call it tip IDs. And this tip IDs will be basically number 4, which is for the thumb, number 8 for the index, number 12 for the middle finger, then 16 for the ring finger, and then 20 for the pinky finger. So these are the tips. And then what we can do is we can put a for loop here, and then we can change this value. So here we can say for, let's say, ID in range. What is the range? From 0 to 5. We are going to repeat this, and here we are going to put in the value. So the idea is that we have our ID number 4. So we can write here tip IDs at number ID. Okay. And the other value, so here you can see it is 8 and here it is 6. So it is -2. So whatever value we have here, -2. So this -2. So this should basically loop and it should tell us for each one of these. But once it tells us that if the finger is open or not, we need to save that. So here we can write fingers is equals to empty, and here we can write fingers dot append. We can append either 1 or we can append 0. So if the finger is open, then we will append 1. If the finger is closed, then we will append 0. So here we will write print fingers. So let's see how that works out. So if we have our hand in, you can see all the fingers are open. If I close, all of them close except for the thumb. So we will discuss the thumb, but let's try the other ones out. So here we have 1, the index finger, then the middle finger, then the ring finger, and then the pinky finger. So you can see it is really good. I can do 1, 2, 3, and 4. There you go. So that is amazing. So what I was saying earlier is that, for example, if you have this pose, it will show you that the index is open and the pinky is open. But for images, we are still going to use this image, that it will show us that there are 2 fingers open, because we are not using all the scenarios. Now, one thing you have noted is that the thumb is an issue. And the reason is that the tip of the thumb is not acting the same way. So we are using the tip at this point. So this is the point where we are using the tip, and we are saying that when it is below this point, because -2 will be here at this point. So this basically is never going below that. If I really push my finger, maybe not even then. So that is not a good way to check it. So how can we check it? Can we say that if this is below, instead we can write -1? Even in that case, it is very hard to bring it below that. Maybe now it will say 0, but it will be very hard. So how can you tell if the thumb is closed or not? So for the thumb, what we actually do is, naturally, when we are closing, we put it on the side. We don't bring it down, we put it on the side. So we can check whether this point here at the top is on the left of the second point or on the right. So right now it's on the right, now it's on the left. So when it comes to the left side, we will say it is closed, and when it's on the right side, we will say it's open. So this is the idea. So let's see how we can do that. So what we will do is we will keep this for loop for the 4 fingers. So we will just make it 1 to 5. And then over here, we are going to create another loop, not another loop, just an if statement. And we will say that the ID number 1, which is the x-axis, is less than this point, ID number 1, and then we will check -1, not the two values below, only one value below, only one landmark below. So if you're not clear about this, I'm talking about this point number 3. So if this point is on this side, then we will consider it closed. If this point is on this side of the point, so here it is on the left, then we will consider it open. So keep in mind, for the left and for the right hand, it will be different. So if you are doing it for the right hand, it will be the same what I am doing. If you're doing it for the left hand, then you can do it the other way around. Now you might say that if I'm using it with the left hand with this code, it will not work. Yes, it will not work. But there is a possibility of checking whether it's a left hand or a right hand. And then based on that, you can change your parameters. You can change the if statement based on that. So it is not something very complicated. It's very simple. But right now we will just focus on the right hand. So here what we will do is, okay, we have already written the code, so we don't need to do anything else. So we can write here thumb, and we can write here 4 fingers. So that is the idea. So let's try this out if it works or not. Okay, we have an error. Must be integers or slices. Okay. Oh, there's no ID. My bad. So there's no ID. We have to get our ID by itself. So this will be number 0. So let's run that again. Okay, then we have another issue. Tip IDs 0, 1. Okay, I think there's an issue with the brackets. So there should be a bracket here. So tip IDs at 0. Yeah. And then the first part of it. So the bracket should be here. And over here, it will be tip IDs -1, and there you go. So it should be like that. Okay, so now you can see it is 0 when it should be 1. So it is basically opposite. So we need to make it greater than. So now you can see all of them are 1. If I put my thumb, if I close it, you can see it says 0. So that's how easy it is. So now if I put all of them closed, you can see it says 0. And if I open, I can open one by one, 2, 3, 4, and 5. And I can get all the detections. So that is good. Now the next thing we have to do, we have to change our image. So to change the image, first of all, we need to know how many fingers did we actually get. So to do that, we can actually, let's go up here, let's comment this, and instead we are going to write here that our total fingers, total fingers is equals to fingers dot count. So this is a method in our list. So we have a list in which we can use the count method to count the number of values present. Of what? Of the number 1. So basically we are saying find how many ones do you have. I think the indentation of this is wrong. So we need to fix that. Okay. So then we can print the total fingers. Let's try that. Oh, it has no attribute counts because C is supposed to be small. Okay, so let's try that. Here we have 5, 0, 1, 2, 3, 4, 5. 4, 3, 2, 1, 0. There you go. So now it's looking good, and all we have to do now is to change our image. So how can we change the image? So here we have the code for changing. So we will bring it in the loop, or what is it? In the if statement. So we will bring it in the if statement, and then we have to change the value over here. So we have to put a value based on the total fingers. So already we have laid down, if it is finger number 1, it should be element number 0. So we can take this total fingers. Wait, what happened? Total fingers minus 1. So if it is 1, it will become 0. So it will take this image. If it is 2, it will become 1 and it will take this image. So this is how it will work. So let's see if it changes. We are taking the shape of 0. We should take the shape of the same image. Even though all of them are same, doesn't matter at this point, but overall it could be different. Okay, so we have 5 now, and then we have 0, 1, 2, 3, 4, 5. So that's how easy it is. 1, 2, 3, 4, 5. And it looks like an animation if I do it fast. And it's running real time, so it looks really good. Now you might say we didn't add 0. We actually never said go till 6. So this value of total fingers can be, let's say, at 5 maximum, right? And then 5 minus 1 is 4. How is it going to 6? That does not make any sense, right? So this is why I put it here as 6. What happens is that when the value of total fingers is 0, it gives the value of minus 1. And in Python, what we have is that if we write minus 1 of the list, it will take the last element. So the last element is the value number 0. So that's why I put the image at the end. So it will take that minus 1 value, and whenever it is 0, it will become minus 1, and it will take the last element, which is the 6th element. So this is the result. So you can see here, whenever it is 0, it gives us that fifth image, which is image number 6. So this is good, and we are pretty much done. The only thing we can do is we can add a rectangle to show the count so that it is a little more appealing, you can say. So here we can write cv2.rectangle. We will put in an image, and then we have to give it the points, the starting point and the ending point, 170. So I have tried out this before, so I know the values that will work properly. So I'm directly inputting those. So then we can put the color, let's say green, and then we can write cv2.filled. So if we run this, you will see whenever we have our image or whenever we have our detection, we get that green rectangle. So this is only coming when we have the hand because it is in the if statement. So if we put it outside the if statement, it will always appear. But I prefer that it disappears whenever the detection is not there. So then we are going to put the text. We will write cv2.putText, and inside that we will add our image, and we will change the text to total fingers, and then we will give in the location, and then we have to give in the font. So we will pick the font, plain font, and then we have to give in the scale. We will keep it really big so we can see 255, 0 and 0, and then we will put 25. So this is the thickness. So let's try that out, and we'll bring in our hand, and if we close, it's 0, 1, 2, 3, 4, 5. I will do it again, 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. So as you can see, it works really well and the detection is really great. But again, if I use these two fingers, it will still show me the image of 2. And if I, let's say, put these 3 up, it will still show me the 3 default image that we have. So if you want to change these, you will have to put if statements. For each of these, you will have to have an if statement rather than a loop. And you can define, if this is the case, then this should be the image. If this is the case, then this should be the image. So each of the fingers can be like a binary. So if that is 0, 0, 1, 1, then you do this. If it's 1, 1, 1, you do this. 1, 1, 0, 0, you do this, and so on. So you can do it like that. Hey everyone, welcome to my channel. In this video, we are going to create a personal AI trainer. We will use the pose estimation running on CPU to find the correct points, and using these points, we will get the desired angles. Then based on these angles, we can find many gestures including the number of bicep curls. We will write the code in a way that you will be able to find angles between any 3 points with just a single line of code. So here we are in our PyCharm project, and you can see that this is the exact same one that we used in our previous video. So we started off with the bare minimum code. So you can see this is all of the bare minimum code that we require to run our pose estimation. And then we created a module out of this. So this is that module which allows us to create these projects very quickly. So today will be one of these examples where we create a project very rapidly. So then here is our awesome project. So this was the demo of how you can actually utilize this to run your module. So these were the things, or these were the files that we created last time. So if you haven't checked that video, I highly recommend that you do go through that video before you continue here. Now today we are going to do the AI trainer. So we have a new folder here called the AI trainer. Let's open that up and let's check out the contents. So here we have a test image. So basically the idea is that we want to find the angle of any 3 given points. So point number 1, point number 2, and point number 3. So this is actually explained here in the summary. So what we will be doing is we will be using these 3 points, and based on these 3 points we are going to find the angle between these 2 lines. So that will tell us how much angle we are at, and based on that we can do some calculations for the gestures or for the posture, so that we can tell the person, okay, you have done this many curls. So what we will be doing is we will be counting the number of curls that a person has done. You can apply it to other techniques as well to see the posture, whether they are using correct ones for yoga or something like that. So the main idea is that we will do this in 2 steps. The first one will be to find the angles. So we will create a method where we can input any 3 points and it will give us the angle of these 3 points. So this way we do not have to worry about getting other angles. For example, if I want for the leg, I will have that information as well. If I want for the arm and the shoulder, I can have that information as well. For the elbow and the wrist, I can have that. So with one single line of code, I will be able to have all of these different angles. So I will just have to specify the landmark number. For example, for this arm, it is 11, 13, and 15. So I can say 11, 13, 15, and it will give me that one. If I say 12, 14, and 16, it will give me for this one. So for this one. So this is the idea, that we will create this method. And the second part is where we will try to find the angle. And no, actually we will have the angle, and based on that angle, we will see how many curls did the person do. So this is our idea. So we will start off with, this is by the way the video. Let me bring it here. So this is the one we will be using. Again, both of these images and videos I got from pexels.com. So you can check it from there, or you can find these documents in my website. So you will find this folder over there. So what we will do is we will right click and we will create a new file, and we are going to call this, let's say, our AI trainer project. So the first thing we will do, we will import our packages. So we will write here import CV2, then import NumPy as NP. And what else do we need? We need time. So we will import that. So all of these packages we have imported earlier. So if you are new and you haven't seen the previous video, you can go to settings, Python interpreter, and you can add, and here you can write opencv-python, and you can hit install, and then you can write media pipe, and there you can install. So these are the two libraries that are the most important ones. Okay, so once we have that, we are going to import our image and the video. So here you can see we have the image, not this one, the test image and the video. So we will be using the test image at first for the angles, and once we have that, then we will use the video for the curls. Now we will write the while loop anyway, so that we don't have to switch at the end. We just can remove one line and it will convert to video. So we will write here first that we have a video capture device. So we will write here cv2.video capture, and we will say this is the AI trainer slash, what is it, girls.mp4, and then we will say while true, we are going to check the success and the image, and we will say cap.read, and then we will say cv2.imshow. we will write here image, and then we will write image, and cv2.wait key and delay of 1. So if we run this, we should get our video running. So let's run that, and there you go. So as you can see, this is quite a big video. It's quite huge. We can resize it. We can write here image is equals to cv2.resize, and we want to give it a specific one. So we will write here 1280 by 720. So let's try that. And there you go. So now this is good, and we are ready for the curls part. But as I mentioned before, we are going to use the image first, and later on we are going to use this. So we are going to comment this, and here instead we are going to write image is equals to cv2.imread, and then we can read our image. So it will be AI trainer slash, what is it, test.jpg. So we can actually put it outside. So let's run that, and there you go. So we are getting our image. So we will check the angle of this, and we will see how we can calculate that. Okay, so that is good. Now we need to find our pose. So to find the pose, what we have to do is we have to import our pose module. So here is our pose module that we did in our earlier video. So here we have the class pose detector. We are going to use that to create an object. Once we have the object, we can use find pose to find the pose, and then find position to get all the data in that list. So here we are going to say detector, the detector is equals to, oh, I didn't import, forgot to import. So import pose module as PM, and then we can write here pm dot pose detector, and we do not need to give any inputs at this point. So then we can come down here and we can write here that detector dot find pose. And do we need to input anything? We need to input the image, and then we need to tell whether we want to draw or not. So by default it's true, so we will draw. And what else? So do we need anything back? No, not really. We can, yeah, we need the image back. So let's run that, and there you go. So now you can see, okay, this is not good. We need to put it inside so that it's detecting again and again. There you go. So now you can see it is detecting the pose, and now we can try to find the angle. But how do we get the landmark values? So we can use the get position. So we will write here lm list is equals to detector dot get position. Wait, why is it not showing? Detector dot, is it, it's find position. Okay, so find position, and then we will write image, and we don't want to draw, so we will write here false. I think there are only 2 arguments, so we can directly write false. Yeah, so that's fine. So let's run that. Actually, we need to print to see if we are getting anything. lm list, and let's do that. And there you go. So this is our list, and we can see we have all these 32 points. So that is good. Okay, so now we can, first of all, we need to make sure that we have a list where we have the pose detected, otherwise it will give us an error. So we can write here the length of our lm list is not equals to 0. Then we are going to do something magical. So what is the magic that we are going to do? So now here the thing is that we can write the code here, but then it will be for this project only. We can write here pass for now. So that will be for this project only, but we don't want to do that. We want to enhance our pose module by adding a method to it. So this pose class, which is the pose detector, it will have another method that will allow us to get the angle of any 3 landmarks. So instead of giving the points, for example 485 and 281, what we will do is we will say we want to find the points between 3, 4 and 5. And because it already has this method and it already has this list, we will make it an instant list so that it is for that particular object. So then we will not have to even input the point value. We just have to input the number. So we need to know which landmark numbers we are talking about. So how can we do that? Let's start by writing our code. So the first thing we will do is we will create a new method. We will call it find angle, or angles. No, find the angle, because it's just one angle. Then we will give in our image. The image is for drawing, so we will input that, and then we will need the 3 points. So we will call it P1, P2 and P3. So these are the 3 point landmarks that we need, and then we can have the flag for drawing as always. So we will keep it as true. Okay, so now, as I said, instead of giving in the points, we are just using the values. So we are using value number 4, value number 3. You can call them index number 2, 3, 4. So these are basically index values. So what we need to do is we need to get the values of the points based on our index value. So how can we do that? So in the find position, you can see we have the LM list. So what we can do is here we can send this LM list back again to our object, but that is not a good way to do it because we already have it. We can just use it internally. So we can write here self dot, And now this is part of that object. So we will write here self dot, and we will write here self dot. So now what we can do is we can write here that our x1 and x1 and y1 is equals to self dot lm list at point number 1. So let's say we want landmark number 3. So that will give us this landmark number 3. But the thing is, it has 3 things inside. It has number 3, it has 485 and 281. So what we can do is we can slice it. So here we will write we need from point number 1 till the end. So it will take this and this, and it will ignore this. So then it will store it in x1 and in y1. You can also do it like this. So you can ignore the first one, and you can remove this one, and you can ignore the first one, and you can take just the last 2. But let's do the first method. Let's do it like this. And then we are going to write here x2, y2, and then x3 and y3. And here we are going to write point number 2 and point number 3. Now, to make sure we are getting the correct points, we are going to draw. So here we will write if draw. We are going to write a circle. So let's just copy because we are lazy. And we will just change this to x1 and x2. Okay, so yeah, that should be good. We can copy this and we can make it x. Wait, what did I do? x1, x2. Why did I do x1, x2? This should be y1. I always make that mistake. y2, x2, and then y2, and then x3, and then y3. Okay, so that should give us, but we didn't call it, so we need to call it here. So we are going to write that detector dot get angle or find angle, and we will give in our image. So now we need to give in the points. So if we go to media pipe and we check for the points, you can see that we want point number 11, 13, and 15, and then 12, 14, and 16. So based on if we want right or left. So the left one is the odd one. So 11, 13, and 15 is the left one. So here I think the right one is visible, so we will use the right one. So 12, 14, and 16, and the draw we will keep it as true. So now let's run this and see what happens. And there you go. So now you can see these have turned blue. So we know that these are the ones that we are using. Should we decorate it more or should we do it later? Let's do it now. So what we can do is we can make it look a little bit nicer, just to make sure that we are using these correct points, because at some point we are going to remove all the other the detection, the pose estimates. So here we are going to create a bigger circle, and let's put it as 15, and let's put this as 10, and we will not fill it, and we will put the value of 2 here. And for the color, let's put it as red. So here we are going to write 255, and we are going to write here all of these as red. Yeah, and then what else? So we will copy this, we'll paste it here and paste it here. We'll make it 2 and 2, and then 3 and 3. So let's try that. There you go. Oh, we forgot to remove the fill. No, we did remove the fill. We didn't do the size. We forgot to change the size. Okay, there you go. So these are the 3 points. And what else? We can do the line as well. So let's do the line before that, because the circles we want to draw on the line. So we will write here cv2.line, and the first line will be on the image, and we will have 2 points, and then we will put the color of white so it's really visible, and then we will put the thickness of 3. So here our first points will be x1 and y1, and then the second one will be x2 and y2. We will copy this, and here we will have, what happened there? Here we will have x3. So 2 will be common for both of them. 1 and 3 will be changing. So let's try this. Nothing happens. Why didn't anything happen? Because I put this in the wrong place. This should be outside. Okay, there you go. So now we have the white line, and so now we can go back and we can make this false, so that we can just focus on these 3 points and the rest will be gone. So there you go. So now we have these 3 points, and we want to know the angle between these points. So we will go back to our module, and here now we need to find the angle. So the angle finding is not actually hard. So here we can write, for example, get the landmarks, and here we are going to write calculate the angle, and then here we will write draw. Well, you know, it's written draw here and we're writing draw here. Very redundant. But anyway, so we will write here angle is equals to, we are going to use math, so we will write here import math. So this is just basic trigonometry, so we don't have to worry too much about this. So what we can do is we can write here math dot tan 2, sorry, a tan 2, and then we have to give in y3 minus y2, and then x3 minus x2. Then we will subtract, and we will write here math dot a tan 2, and then we will write y1 minus y2, and then we will write x1 minus x2. So again, I'm missing some brackets, so that should be good. So this will give us our angle in radians, so we can convert it into degrees. So math dot degrees, and there you go. So if you have 3 points and you want to find the angle between the 2 lines, this is the method, this is the equation that you can use. So here we can simply write print angle, and we can see what exactly is our angle. Okay, what happened there? So there's a mistake for sure. It's the brackets. Yeah, this is extra. So yeah, I put 1 extra. My bad. Okay, so here we are getting our angle 87, which makes sense. Like, it is almost 90 degrees. You can see that. So 87.3, it's not bad. So what we can do is we can put this on the actual text or the actual image so that we can see. So we can write here cv2.put text, and we will write image, and we will write the angle, but let's convert it into integer, and then we will convert it into string, otherwise it will not accept. And then we will write here the value, so the position. So here we will write x2. So this is the center point. So we have x1 and x2. These are the further points, and x2 is the middle point. So we want to write the value near the middle point. So we are using x2, but we don't want to write it exactly at that position. So we can subtract like 20 from it, and then we can write y2, and we can, let's say, add 50 to it. So we can change these values if we are not satisfied. Okay, then we can write cv2.font. Let's pick the plain one, and then we will write the scale and the color. So color, let's put purple, and then we will write the thickness. So let's run that. There you go. So we are getting 88, 87. So that's good. The X is bad. So let's do, we did minus, right? So minus 50, let's say. Yeah, it's better now. Maybe let's convert this into blue. That's more visible. No, the background is a little bit black, so it's not that visible. Maybe red will be more visible, or green. Yeah, red is not bad. So 88 degrees is what we are getting. And sometimes what happens is that we get a negative value. So for that case, we can write here. Should we actually, let's remove this. And for those cases, we can write if our angle is less than 0, then we will say our angle, we want to add 360 to it. So 360 minus whatever the value will be. So that will solve that problem. So now what we can do is we can use any 3 points to find our angle. So let's say I want for, this is for the right one. So we can say here right arm, let's say. And then I can do the exact same thing with just one single line of code. I can write here left arm, and I will just change the values. 11, 13, and 15. And now you will see it will do for both of them. And that is pretty amazing. So it is telling the angle for both of them at the same time. So the last, the one that is hidden is not very clear, so you cannot rely on that angle. But the one that is here is quite good. So we can remove this. So now we can try this on our video. So for the video, as I mentioned, we want to do it on the left arm rather than the right. And by the way, you can do it on the legs as well. So it's up to you now which 3 points you want to take. For example, you can take 23, 25, and 27. So it will tell you the angle between these two lines. Then you can use 24, 26, 28. It will tell you the angle between these. So it is up to you which ones you want to use for your own project. But for now, we will use the left arm for the bicep curls. So now we will remove this. We will uncomment this, and we will remove the image part. And let's try to see if we get the angle. There you go. So now we are getting our angle. And as you can see, probably it's going to negative and all. So that's why it's giving this value. So what we can do is we can find the minimum and the maximum. And based on that, we can check if it has reached that point or not. So let's try to figure out the minimum and maximum. Now, the good thing is if you click on the window, it will stop. So we can check our values very easily. So here you can see it's 338, but that's not the last one. So here I saw 190 something. Yeah, 180 probably. Or let's say 200. Yeah, 200 is not bad. Or just to be on the safe side, we can keep it a little bit higher, like 220 or something like that, so that it goes to 0 easily. And then over here, we can see it goes to 300 something. So 340, but again, might not go always there. Oh, 330 maybe, 20 or 310. I can see it goes again and again to 328. So it went to 340, 340. Oh, it's going to 40. Now it's 28, 27, 29. Okay, so to be on the safe side, we can say that it is 20, right? So, or we can say 15. So what we can do is we can convert our range. We want it from 0 to 100. We want to know how much curl we are at. So the percentage of curl. So at the 0 point or at the 100% point. So what we will do is we will create a percentage and we will say that, did we import NumPy? Yes. So we will use NumPy to convert our range. So we will say numpy.interp, and then we will give in our angle, not range, angle. Oh, we didn't get it back. That's why it's saying this. Angle is equals to, so I think I forgot to return. Yeah, so we need to return angle. So that will return our angle over here, and then we can use this here. Angle is equals to what else do we need? So we need the first range. So our range will be, let's say, 210 to 310, let's say, and we want to convert it into 0 to 100. So this is already 100, so we can easily just subtract. But if we had a difficult range, you can use this method. So that should be good. So let's print out this value, and we will print out the angle. Not the angle, the percentage. So, or we can print the angle and the percentage. That will be good to see. Are we printing anything here? No. Okay, that's good. So we can run this. So here we can see. So it's 0, going 100%, then going back to 0, then to 100%, going to 0, 100, 0. Excellent. So now we can see that we are getting the correct values. So we should not face any issues because we have taken quite safe values. If you go too far, you might not get good results. So you have to check the trade-off between accuracy and taking the risks of getting error. Okay, so then we are going to check when are we reaching the first curl, when are we reaching the second. We need to count. So here we are going to go up and we are going to define two things. The first one will be count, which will be 0, and the other one will be direction, which will be 0. Now we will have two directions, direction number 0 and direction number 1. Direction number 0 will be when it is going up, and direction number 1 will be when it's going down. So we will consider a full curl only if it does both of these. So it goes up and then it goes down to 0. So from 0 to 100 and 100 to 0. So if we get that, then we will consider it as first curl. So we could do the other way around, but I want to keep it like this, where we have the complete curl if we go back and forth the whole thing. So we are going to write here that we want to check for the Dumbo curls. Okay. So then we are going to write here that if our percentage is equals to 100, and then we are going to check if our direction is equals to 0. So this is the first direction, it means we are going up. Now you might say, why didn't you just write and here if percentage is 100 and if direction is 0? I will tell you why later. There's the reason. So then we are going to say count plus equals 0.5. So we will add 0.5 to the count. So if it's going up and it has reached 100%, it will be 0.5. And then it's going down and it reaches 0, then it will be 0.5. So that will be a complete curve. So what I can do now is I can change the direction. So direction is equals to 1. And then I can check here that if my percentage is equals to 0 and my direction is equals to 1, then I will write count is equals to plus is equals to 0.5. So the same thing that we did earlier, and then we will make the direction 1. No, we will make the direction 0. Okay, so this will keep adding to our count, and this way we will know which direction we are moving and how many counts did we have so far. So here we can remove this and we can simply print the count. So we can write here print count, and let's see what do we get. So 0.5 down 1, 1.5 down 2, 2.5 down 3, 3.5 down 4. So excellent. So if you okay, let's just display it first and then I can discuss. So we can display it like this, cv2 dot put text, and we can write here image, and we can write our string. So we can write inside that integer. So if you want to directly show the decimal places, so if you want to show the 0.5 count as well, then you can keep it like this. So you can write simply count, but I don't like that. Or let's try it now. I will show you and then we will change it. And then we will write here, let's say 50 and 100. And then we will write cv2 dot font. Let's put the plain one, 15. And then we will put 255. 0, 0, and then 25. Actually, these are very big values. We will put big values later on, but for now we just want to see if we are getting the output properly. Okay, so what is the problem? It's not callable. Is that the issue? Oh, okay, I forgot to write comma. Okay, so here we are getting 1.5, 2, 2.5, 3, 3.5. That is good. So what I was saying is that if you don't want that, you can simply write here int, and then you can put it like that. So if we see that now, it's 0, it becomes 1, 2, 3. So it's up to you which one do you prefer. Okay, so now that we have this, we can make it a little more appealing. So what we can do is we can first of all add our FPS. So we didn't add that earlier, so we can add it now. So we can write here ctime is equals to time dot time, and then we can write FPS is equals to 1 divided by current time minus the previous time, and then we will write our previous time is equals to current time, and then we will put the text. So we can copy this and we can paste it here, and then we can change it to FPS. So that should be good. Now we need to put previous time as 0 over here. Okay, so that will give us the time, and we can comment this to check the FPS. So there you go. So we are getting good FPS. Now this video is 1080p and we are reducing the size of it, and that's why it's giving a lower frame rate. Otherwise you will have a better frame rate if you because here we are resizing. So if you directly use maybe this size or even lower, you will get higher frame rate. Okay, so then what we can do is we can put our the number of count in a box. So let's create a box. So I have already checked the values of this box, so I will directly input it. So we will write here cv2.rectangle and we will put in our image, and we will put in 0, 450, and then 250 and 720. So this is for a 1280 by 720, which is HD image. So it is for that. So 255 and 0, and then cv2 dot filled. So this will give us a green box. And what we can do is we can uncomment this and we can format it. And then here we need to change the value. Let's put it as 45 and 670. So let's run that. There you go. Okay, we need to change the size of this. So 15 and 25. Okay. So there you go. So now we are getting this nice and big, so we can see what is happening. That is quite good. And it is giving us the angle. Do we need the angle? No, I don't like the angle. Let's remove the angle from here. So let's run it again. There you go. So now we are getting without the angle, so it looks good. Now what else can we do? Okay, let's put the bar. So if you remember, we did it in one of the other videos for the volume gesture control, so you can check that out as well. It was to control the volume of a computer using your hand gestures. So we use the bar in that one as well. So here we are going to use the bar again. So for the bar, first of all, we need some values. So we will write here bar is equals to np.interp, and we will convert our angle from the range of 220 to 300, not 300, 310, and we will put it as 650 and 100. So this is the maximum value of our bar. No, the minimum value of our bar, and this is the maximum value of our bar. Because the OpenCV convention is opposite, so this is the minimum, this is the maximum. Okay, so why is not giving a space here? Okay. So then we need to create that rectangle. So here we can create that rectangle. We will copy this because we are lazy. We will copy it twice, and we will also put the text. Okay, so now we need to change the values here. So the starting will be 1100 and then 100. Then we have 1175 and we have 650. Then we have 1100 here, and then we have our bar value. So integer bar, not bad, bar, and then we have 1175 and then 650. So for the text we will have our percentage. So we will make a string, and we will write here integer, and then we will write our percentage, and at the end we will write %. So this we will display at 1175, and the size will be 4 and 4. Okay, so we can write here that this is for our bar. Draw bar, and let's say we write here show, or let's write draw curl count. Okay, So then let's try it out. There you go. But the bar value is not changing. What did we do wrong? Oh, so apparently the value of the bar is not changing because it is filled. Come on. So this should be, let's say 3, and let's try that. Yep. So it goes down, it goes up, it goes down, it goes up. Now, one more thing we can do is when it reaches the 0 or the maximum position, we can change the color so that we know it's like when you reach a certain point and or you press a button, it changes color. So you kind of get a feedback. So it looks good. So that is the reason why we put an if within an if. So here we are going to write color is equals to, by default, we are going to write the color as purple. And if it reaches, we are going to change the color as green. So we will put the color as green. So 255 and 0. And the same thing we can do for our 0. If you want to change the color for 0, make it different than the other ones, you can do that too. But we are going to keep it like that. So here we are going to write, here color, and then here we are going to write color, and here we are going to write color. So all of them are same. So now it's green, purple, purple, green, purple, green, green. Yeah. So that's how you can tell if you have reached the correct point or not. So as you can see, it works very well. And again, if you want to use a webcam, you can simply enter the value or the ID number of your webcam, and it should run pretty much the same way. Just make sure that your face is visible within the camera, and you are at a good distance, because a lot of this depends on the face as well. So if you are not within the if your face is not in the camera, it will not detect properly. So that is pretty good. So I had a hard time finding these videos with bicep curls, so that's why I just had this one, but I will try to find some more. But yeah, so that is the idea. The error is because the video ends, that's why it gives this error. It's not something that we made a mistake here. Hey everyone, welcome to my channel. In this video, we are going to create a virtual painter using AI. We will first track our hand and get its landmarks, and then use the points to draw on the screen. We will use 2 fingers for selection and 1 finger for drawing. And the best part is that all of this will be done in real time. So the first thing we will do here is to go to canva.com. And if you're not familiar with Canva, it is basically a design tool. It's an online website that helps you create all these different designs for brochures, business cards, flyers, whatever you want. You can basically design here. So this is a free website, so you can go and start. You can start by just signing up. So here we have a canvas of 1280 by 720. So we are expecting our webcam to be of this size. That's why we are using this size. So the idea here is that we are going to create a design to actually make it look more appealing and make it look more like a software. So this is up to you. If you want to skip this step, you can do that too. There will be files to download from my website, the ones that I already did. So if you want to skip, you can go ahead and do that too. But here we are going to start off with a rectangle And what we will do is we can put it on the side, but the issue with the side is that it will be hard to select different elements. So what we will do is we will put the menu on the top. So our menu will be here at the top. Now for the width, let's keep it at 100. 100 is too small, maybe 120, 125. Yeah, that looks good. So then we can lock this, or let's change the color first. So I like this blue, or maybe this one. Yeah, this one looks better. So let's lock this so it doesn't move around. Then we are going to add, let's add the logo first. So I'm going to go to photos and we'll write here logo. No, it's in upload. My bad. So I have my logo here. I'm going to place it on the side. And yeah, that looks about right. Then we are going to add some brushes. So here we will go to the elements and we will search for brushes. So let's write here brush. Okay, so these are strokes, but we are not getting actual brushes. Here we have, let's write paintbrush maybe. Yeah, I think now we have better results. I want to look for something that is free. This is free. Okay, so maybe something else that is free. This is free as well. So I'm looking for something free so that everyone can use it, not just the pro users. Maybe this one. No, it's pro. This one is free too. Do we have a color option? I think this one is the best. Okay, let's keep it this way. And if we want to, we can change it later on. So let's take this part right about here and we will zoom in and maybe a little bit smaller. There you go. So I think that looks good. Now the good thing is that most probably this is an SVG file, so we can change the color for it. So let's say we want pink. What is that? Purple. Let's try pink. And what we can do is we can have another one that is a little bit bigger than this at its back. So that will indicate that this has been clicked. So we can put it, okay, let's change the color first. We can put it as white or gray or dark gray. Let's put it at the back. I think white will be better. Okay, I'm no designer, I'm just eyeballing this. So I'm gonna put it as white. Yeah. Okay, so then what we can do is we can copy both of these and we can paste them here. So somewhere in the middle, then we can paste another one. And then we need an eraser. So we don't need the last one actually, the one at the back. Or do we? Okay, let's keep it. Let's keep it for now. I will tell you why later on. Okay, so now we need an eraser. So let's write here eraser. Okay, this one is pro. This one is free. No, not really. All of these are paid. Oh, this one is free. Yeah, I think that could work. So let's put that be a little bit bigger. think I'm putting it too big. Anyways, you can change the design later on. We are learning the concept here. Or let's just make it a little bit smaller. So I think that will be better. So we can grab these two and we can place them here. This one in the middle. This one a little bit further. Okay, I think that is better, and then we can make this a little bit smaller, and there you go. So I think that looks good. Now what we can do, okay, these are not at the top. We need to put it at the top here. Okay, so now what we will do is we will change the color for these. So the first one is, let's say, pink. The second one, let's say, is blue or dark blue. In between, maybe. This looks weird. Okay, let's keep this as blue, and then the last one, let's keep it as green. So these are the, let's say, 3 colors that we want. And then what we will do is we will, this doesn't seem right. I think at the back needs to go higher, maybe. Yeah, maybe like this. Okay, I'm going to copy this and we will paste it here. So we will put it at back, and the same thing to the last one. Okay, so you can move it around with your keys, your arrow keys. So maybe a little bit higher. Again, you can spend a lot of time on this, but we are going to skip that. We will not put a lot of effort here, just for demonstration purpose, but you can, of course, go ahead and try a lot of different things. So now what we will do is we will copy all of these. We will duplicate them. So here you can see, or let's change the size first. So we already know that our size is 1280 by 125. So we will go to resize and we will change this to 125, and we will copy and resize, or you can resize, it's up to you. I'm going to press resize, so it will do it on the same one. Then I can unlock this and I can grab all of this and I will scale it up. So it should fit perfectly because it is the same size. There you go. So this is the image that we need. So we are going to copy this 4 times because we will have a selection for each one of these. So we can delete the selection for this and the selection for this. And this is the first one. So first one, this is the one selected. The second one, this is selected. And for the third one, we will have this one selected. And the fourth one, we will have the rubber selected. So here we are going to, it is white. Let's change this to, well, let's change this one to the same color as this. And let's make it a little darker. Let's make all of them darker. So yeah, and then let's make this, it's a black. That's too much. Okay, I think that is enough indication. So we just need an indication that that has been pressed. So that should be fine. So now what we can do is we can download all these 4 images. And the idea here is that whenever we detect a click, we are going to change these images. So we will see which one do we need. So if we have clicked the first one, then we will change the image to this. If the second one is clicked, we will change the image to this, then the third one, and the fourth one, which is the eraser. So at any given point, only one of them can be selected. So that's the idea. So we can go and we can write here that this is our virtual painter, let's say, and we can download all of these in JPG or PNG, whatever format you want. Let's do it JPG, and we can download all of these. So here I am in the PyCharm project. Now this is the same project that we have been using for the hand tracking, for the finger counter, for the hand, volume control. So we have done quite a bit of projects earlier than this. So this is the exact same, project. And you can go to File, Settings, and you can see that we have already installed our media pipe and we have already installed OpenCV. But if you are new, you can go to the add button. You can write here OpenCV-Python, and you can install this, and then you can go to media pipe. Media pipe is the Google library that we will be using for hand tracking. So you can download and install this. So this is the main idea. Now what we will do is, first of all, we will right click this and we will open it up in the Explorer. Now, once we are in our project, we are going to create a new folder and we are going to call it header. So we will have our header images in here. So these are our images that we downloaded. So I will copy all of this and I will paste them here. And now you can see that these are our header files. So we have a total of 4 header files. So when we go back to our PyCharm project, you will see that we have a new folder by the name header, and we are going to use that for our images. So then we are going to right click and we will create a new Python file and we will call this virtual painter. So now we are going to import our libraries. So we will write here import CV2, import NumPy as NP. And then we will need import time if we want to show the frame rate. And then we will also need import OS because we need to access these files. So we will need that. What else? We also need our hand module. So we will write here import hand tracking module as HTM. So this will be our hand tracking module. Now, if you are not familiar with this, if you haven't watched the previous tutorial, then make sure you go ahead and look at that, because this is the tutorial in which we went step by step and we created this hand tracking module. So this is very important. This basically tracks the hand. So if I run this, you will see, if I right click here, this should open up my webcam. And if I bring in my hand, you can see it tracks the hand. So this is the idea of the hand tracking module. And based on these values, we are going to do some painting. Okay, so now, first of all, we are going to import our images. So that is the first thing we are going to do. We will write here that our folder path is equals to header. So these are the header images, and we are going to say that my list is equals to os.list directory, and then we will get the name of all our folder path files. So this is the idea. If we print this out, if we print my list, you will see that we get all these images name. So here you can see 1.jpg, 2, 3, and 4. So what we have to do is we have to import them so that we can use them later on to overlay on the top. So here we are going to write for image path in my list, we are going to loop and we are going to import. So we will say that our image is equals to cv2.imRead, and we are going to read from a string, and that will be the folder path slash the folder, the image path. So this will be our complete path that we need to read from, and then we are going to store it in a list. So let's call this list overlay list. So this will have all the images that we want to overlay. So we will write here overlay dot append, and we want to append our image. Okay, so this will overlay our images. No, it will import all our images. Now what we can do is we can print the length of our overlay list, so we can see that whether we have imported all of them correctly or not. So let's run that. So we have imported indeed 4. So that is good so far. And next, what can we do next? Next, we can run our webcam. And then once we have our webcam, we can simply overlay one of these images by default. So we can call our image, let's say header, and we are going to give it an initial value. We will say that overlist at 0. So now this is our image. So whenever we get our original image, we are going to overlay this on top of that. Okay, so this is good for now. What we can do next is we can create our loop and we can run our webcam. So here we are going to write cap is equals to cv2 dot video capture, and we will say that device number 1. Now you should write device number 0 because I have multiple cameras, I'm using 1. Then I will write cap.set. Now this is important because we want the exact same size. We want 1280 by 720. So we have to make sure that the width and the height are exactly the same. So we are going to write 1280 by 720. Then we are going to write here while true, we want to run our webcam and we want to get our images. So we will write here that the success and the image is equals to cap.read, and then we are going to okay, let's just display it first. So cv2 dot wait key is 1, and we have cv2 dot ImShow. I will say image and image. So that should be enough. So let's run it. We have an error. Oh, I wrote ImRead. No. ImShow. What happened there? Okay, so there you go. So this is our image and you can see my hand. So what we will do, we are going to overlay our image now. So how can we do that? So we can simply write that our image, so you might think it's a little bit difficult, but it's not. It's very easy. Because our image is a matrix, we just need to define where is the location of this new image. So we will slice it. So here we are going to say that our height is from 0 to 125 because we know that the image size is 125. And then the width we are going to say is from 0 to 1280. So at this region, we are going to say our image is equals to header. And that's how simple it is. So if we run this, there you go. So now you can see that we have our image, and on top of that, we have overlaid our first image. Now this is good because by default, we want our first paint brush selected, which is the pink one. So we are already up to a good start. So here we can write that we are setting the header image. Setting the header image. Okay. So this is good, and now we can just separate this because we are going to write our code over here. So what else can we do? Now, the next step is, before we go into the details of the project, let's split it up into pieces. So first of all, we will import the image. Okay, so that's the first step. We have pretty much already done that. There is another thing we need to do. I will tell you later. This is the first step. Let's write it here. 1. Then the second step is that we want to find the landmarks. So find hand landmarks. So this can be easily done with our hand tracking module. So that should not be an issue. Then number 3 is basically checking which fingers are up. So check which fingers are up. Now this is because we want to draw when one finger is up, which is the index finger, and we want to select only when 2 fingers are up. This will allow us to easily move around the canvas without painting. So when our 2 fingers are up, it will not draw anything. If we want to draw, we have to put 1 finger up, the index finger. So this will allow us to easily navigate through the canvas. Then we have the selection mode. So we will check here at the 4th stage. We will say if selection mode, which is when 2 fingers are up, 2 fingers are up, then we have to, we have to select, not draw. Then in the 5th one, we have to check if we have the drawing mode when index finger is up. So this is the idea. Now let's go on to the next parts. Actually, do we have a next part? No. So this is pretty much it. We have 5 different steps. We are going to go step by step and see how we can achieve each one of these. So the first thing is that for importing image, it is pretty much done. The only thing we have to do is we have to flip the image. So we are going to flip horizontally. This is because when you are drawing, if you want to draw on the right side, then when you move to the left, it will draw on the right. So to flip the image, we are going to write here flip, and we will write image, and we want to flip in the first direction. Now this will allow us to solve that problem. So let's try that. So now the image is flipped. So if I go on the right side, it's going to the right. If I go on the left, it's going to the left. So it will be easier to draw because it will be more intuitive. Now the second step here is to find the landmarks. Now the landmarks we can find, but we need to import first. So we are going to write here that our detector is equals to hand tracking module dot hand detector, and then we are going to give in detection confidence. So this is up to us what value do we want to use, but we are going to keep a high confidence because we want it to be good in painting. We don't want a lot of mistakes here and there. So by default it's 0.5. We have changed it to 0.85. Then over here we are going to say that our image is equals to detector dot find hands, and we are going to send in our image. So this will draw on our image and it will detect the hand. So let's try that. There you go. So now we can see it's detecting properly. So that is good. The next step is to get all the landmark positions. So we are going to write here landmark list is equals to detector dot find position, and we will write image, and we do not want to draw. So draw is equals to false. And then we can check if the length of our landmark list is not equals to 0, not equals to 0, then we are going to do something. Let's print the LM list. So let's try that. So let's see if it prints. There you go. So it's printing the landmarks. If I move around, if I go out of the image, it does not print anything. If I come back in, it prints the, what do you call, landmarks. So that is good. So now that we have this, we need to know the tip points of our index finger and the middle finger. So what we will do is we will call the index finger tip as x1 and y1. So we will say x1 and y1 is equals to LM list at point number 8. So this is the landmark 8. So here you can see this is the landmark 8, and we have the value of 729 and 396, for example, in this case. So this is the tip of our index finger. So here I can write tip of index and middle finger. Okay, so then as you can see, it is basically the first and the second element, not the 0, 1. So here we have to write from 1 till the end. So we will write it like this. So it will grab only these two. So we are unpacking them here. So x1 and y1. So we will do the same thing here for the middle finger. And for the middle finger, we will write x2 and y2. And the number for middle finger is 12. So that should be good. So now that we have our landmarks and everything is good, now we need to check which finger is up. So this thing we did in one of our previous videos, and that was, I believe, in the finger counting project. So if you remember here, if we go back here, so here is the code that when it is thumb, it will check if it is up or down. Then it will check the rest of the 4 fingers if they are up or down. So, and then it will give us the total finger count, and it will also give us the list. Where is the list? Yeah, the fingers is basically the list, which will tell us which of these are up and which of these are down. So what we can do is we can pretty much copy paste this part, and we can create a method in our hand tracking module. So earlier we did not do it as a method in our class, but this time around, because we are using it again and again, it is better to create a class rather than putting it in different projects every time. So this is our hand tracking module. We are going to open that up, and you can see right now we have only 2 methods, find hands and we have find position. So next we are going to put another method, and that will be called fingers up. So we will write here def fingers up. So that will tell us which of the fingers are up. So we will go to our finger counter project, and from here we can copy. So we have from fingers till this part. I think that should be enough. So we will copy that, and here we are going to paste it. So what we are doing is we are first creating a list called fingers, and then we are basically checking if the tip of our thumb is on the right or on the left. So that will tell us if it's open or closed. And then for the fingers, we are checking if the tip of the finger is above the other landmark, which is 2 steps below it, or it is not. So if it is below that, then it means it is closed. If it's above that, it means it is open. So it is storing the value of 1 when it is open. It is storing the value of 0 when it is closed. But why are these errors over here? These errors are here because it does not recognize tip IDs. And tip IDs was something that we declared over here. So this is the list. So we can copy that, and in our module, because we know that it will not going to change, the tip numbers, the tip IDs, they are not going to change. We are going to write it in our initialization. So we will write here self dot tip IDs is equals to this. So now if we go back and instead of just using tips, we use self.tips, it should work. So we will do that, and there you go. So that works. But now the LM list, it doesn't recognize it because we did not define it as a self, as an instance. So we need to write here self.lmlist, and I can copy that self again, and we can paste it here. We can paste it here. So we can paste it here, we can paste it here, and here, and here. So what happened now was that not only we are returning this LM list when we find the positions, we are also storing it so that if we want it in our other functions or our other methods, we can use it as well. So we do not need to send it out and then receive it back again. Internally, it is available for us to use. Okay, so that should be good. And if we just return this fingers up, it should give us if the fingers are up or not, which of them are up or not. So we can just return the fingers. And if we go back to our, let's close the finger counter. If we go to our virtual painter, here we are going to ask, we will say that detector dot fingers up, and do we need to send something in? No, not really. So that is good. We don't need to send anything, and we can simply receive the values in the variable or the list fingers. So let's print that out. So fingers, and let's remove the previous print. So let's run this and see what happens. So something is out. Oh, it needs to be inside this. My bad. Okay, so this is our image. I will bring in my hand. Oh, nothing is happening. Why is that? Okay. So it takes a little bit to detect. Now you can see how many fingers are there. Okay. The issue is, I will tell you what the issue is. For the thumb, it's showing 1 when it is open, when it is closed, and 0 when it's open, because we are not checking the left and right. So this is an issue that needs to be solved more precisely, but for now, we'll just change this. What was it before? It was greater than, so less than. So by writing less than, it will solve the issue for now, but later on we do have to fix this. So I'm not going to fix it now for this one, but in this case, you can only use your right hand to draw. So if you use your left hand, it will be an issue. Actually, it won't be an issue because we are not using the thumb at all, but it will give you wrong values. So here you can see the thumb, you can see 2 of them, then 3, then 4. So you can see all of these fingers, they are being detected properly. So now if I do this, I should be able to select any of these. And then if I do this, I should be able to draw. So this is the main idea. So we need to check. Now we know that which fingers are up. Now we need to check if it's selection mode or it is drawing mode. So how can we do that? That is very simple. Let me bring that in because I will forget again. Okay, so now we need to check if the first element. So we have fingers at first and fingers at second. If both of them are up, this means if both of them are true, then it means it is selection mode. So we will print here, say selection mode. And if that is not the case, we will write here, then we will write here that this is equals to false. We only have the index finger up. Then we will say drawing mode. So this is the idea. Now what we do after that is a different story, but for now we just want to check if it is able to understand this or not. So let's try that. We should remove the previous print. Let's remove that. Let's run this. So this is selection mode because two fingers are up, and now it's drawing mode. So now it's working very well. We can see when it is, so when it is nothing, it doesn't do anything. When for detection, you have to make sure a lot of the image or a lot of the hand is available in the image. So yeah, so this is drawing mode. We can draw. This is the selection mode, and everything is good so far. Okay, so the next step, what we can do is we can change, or we can draw some circle around it. So here, if it is selection mode, let's draw a rectangle. So we are going to write here CV2 dot rectangle, and we are going to write here image, and then we are going to write that we want from x1 till y1 minus, let's say 15. We want to go above because we are creating let's say a rectangle using 2 points. So we don't want to just give those points. We want to make it a little bit higher and a little bit lower. So then we are going to use x2 and y2, and this time we will make it plus 15. So then we will give it a color. So let's say 255, 0, 255, this is purple, and then we will say CV2 dot filled. Now we are drawing a rectangle here because we are going to draw a circle when it is time to draw. So for the circle, we are simply going to write here CV2 dot circle, and we are going to give in our image, and we are going to draw from x1 and y1. So we will write here x1 and y1, and then we are going to say 15, and the draw color again 255, 0, 255, and then we are going to write CV2 dot filled. So this will be a visual indication of when we are in selection mode and when we are in drawing mode. So for selection it will be rectangle, for drawing it will be circle. So let's try that out. So here it is rectangle, and then if we do this, it becomes circle. So here the detection is not that good, but still you can see the rectangle is very small. 15 is not a good value. Let's make it 25 and 25. Yeah, now it is better. So here I can say it is selection mode, and here I can say it is drawing mode. So it will be easy for us to detect. So my hand should be really back, and then I should be able to draw easily. But because I'm near to the computer, so it's a little bit difficult to do it this way. But it should work fine. So far we have done well. Okay, so we have the selection mode now, and we have the drawing mode. So let's work with the selection mode first. What we have to do now is we have to check if we are at the top of the image. Now, if we are at the top of the image, we are going to change our image or selection mode based on the location. So first of all, we will check if y1 is less than 125. So this was the value of our header. So if we are in the header, then we are going to do something. So we will say that if our value is between 250, if our x1 is between 250 and 450, then it means it is clicking the first one. So here, let me just write it here, checking for the click. So that is what we are doing here. So we will write here that if this is the case, then our header is equals to overlay list at 0. So that's the first one. So by default, it is the first one because we are using it here. The value of header is already, where is it? Yeah, it's already the first one. Then we are going to copy this and we are going to paste it down here. And we will write that else if the value is between 550 and 750. So these values I have checked before. So if it's not the same, we can change a little bit. So then it is 750, then it should be overlay list 1. And then we are going to copy this, we will paste it here, and then one more time. So we have a total of 4. So here it will be 800 to 950, and this will be 1200 and 1050. So this will be 2 and this will be 3. Okay, so let's try that out. So if we move around, we should be able to select. So if I go up, you can see it selects. If I go here, it selects. If I go here, it selects. So wherever I go, it selects the correct one. And the visual indicator is quite nice. So it tells us which one did we select. And if I go with one finger, it's not going to do it, because this is the drawing mode. In the selection mode, we can select. Okay, so that is the difference here. So now we are able to select properly, so that is quite good. Next, we are going to change the color. So whenever we select something, we want to indicate that the color has changed. So here, for example, for the drawing circle or even for the rectangle, we want to change the color for it. So what we will do is we will declare a color. We will go up here, and over here we are going to say, now the first image is for purple. So if we go to the header and we see the first image, it is for purple, or you can say pink, whatever color you want to. Anyways, so we are going to say that by default our draw color is equals to purple. So whenever the value is selected, another value is selected, we are going to change this draw color. So, and we will use it to actually draw. So instead of putting a random color for the rectangle and for the circle, this is the color that we are going to draw. And let's draw it after we have checked for the click. Okay, we will put it here. Is it in the if? No, it should be here. Okay, so what can we do now is that we can change this color individually. So here we will say that draw color is equals to, for this case, it should be purple. So it should be 2550255. And for the second one, it is blue. So it is BGR. So this should be on and this should be off. And then we have green. So BGR. So this should be 0. This should be 255 and this should be 0. And then for the eraser, we will just make it black. So black will erase everything. So we will make it 000. 255, 255, 255 is 1 and 000 is black. So let's run that. Let's try this. So here our color is purple and both of them are purple. We go to selection mode and now it's changed to blue. You can see for both of them it's changed to blue. We go to green, and now you can see it's changed to green, right? So, and if we go to the eraser, it's changed to black, so we can erase it. For the black, actually, we can make an exception for the black, because for erasing, normally the tool is quite bigger. But again, we will discuss that later. So now this is done. So the selection mode is done. We are able to select our color and it changes the color. That is perfect. Now what we need to do is we need to draw. So we already know when we are in drawing mode, we now need to draw based on our points. Okay, so now the easiest method, and this is one that I have been using before as well, because it is very simple. Whenever you are learning a new concept, you should go with the simple thing rather than the most advanced or complicated one. So earlier what I did was I created using simple points. So whenever you have a point, you just draw that single circle, and then whenever you move the finger, you draw the circle there as well. But the issue with that is whenever you have a rapid movement, it will not draw continuously as a line. It will have some gaps. So that is not a good way to draw. So what we will do now is, instead of drawing just a circle, we are going to draw lines. But the issue with lines is that we need a starting point and we need an ending point. So here, whatever current position we are in, we just have that single point. So we need to know the previous point as well. Once we know those both points, then we can simply draw a line. So let's draw that. So here we are going to write that our CV2 dot line, and we are going to draw on our image. And where exactly do we want to draw? We are going to draw at our X previous position and Y previous position, and then the new position, which is X1 and Y1. Then we are going to say which color do we want to draw it with. We are going to say the draw color. And then we are going to give in the thickness. So here we can declare a variable. We can say that it is brush thickness. And if we want to change it, we can change it from the top here. So here we can create our variables. And we can write here that, let's say our brush thickness is 15. So we can easily change it up. And now we have the X and the Y previous. So we will go up here and we will declare that the X previous and the Y previous are 0 and 0. And then we will go down here. Now the issue here is that at the very first iteration, at the very first frame, we will not have any XP and YP. We will have the value of 0, 0. So it will draw a line from 0, 0 to whatever the point you are at. And that will look really bad. So this should not be the case. So how can we fix it? We can fix it by writing here that if our XP is equals to 0 and our YP is equals to 0, it means it is the very first frame that we have detected the hand, or we are starting to draw. Then we are going to say that XP and YP is equals to X1 and Y1. So instead of putting 0, 0, we are saying whatever value you are at, draw exactly at the same point. So instead of drawing a line, it will just draw a point. So the very first time we see our finger, it will just draw a point instead of a line. After that, it will keep drawing as a line. So whenever we have the new point, we are going to say that our XP and YP is equals to our X1 and Y1. So these are our previous points. So it will keep updating those. So hopefully that was clear. Now let's try to run it and see if it draws. So here, if I do this, it is drawing, but it is removing at the same time. So as you can see, it is drawing something, but it is removing. If I go really fast, then you can see it is drawing. So this means that our image is updating every iteration. So we cannot draw on our actual image. So if we want to do that, we will have to do something else. I will tell you what that something is later on. But for now, we need to create a new canvas on which we can draw. So what we will do is we will go up here, and at the very top, we are going to create a new image. And we are going to call it image canvas. And this will be the canvas on which we will draw. So we are using NumPy to draw our canvas, and we will use the zeros method. And the size is 720 by 1280. They use height before the width, so we are writing it like this. And it has 3 channels because we want colors. And it is unsigned integer of 8 bits, which means it will have 0 to 255 values. So that is pretty much it. And now, instead of drawing on our original image, we are going to draw on the canvas. So where did it go? Here. So we will copy this and we will paste it here, and we will say image canvas, and we will show the image canvas as well. Canvas. Okay, so let's try that. So now we should have 2 images. So this is the image canvas and this is the original image. I will keep this at the top, and if I bring in my hand and if I draw, now you can see it draws, and that is very very satisfactory. Okay, so this is the idea, but now the thing is it's not drawing here, which is fine. If you want to, you can draw there as well, and I will show you how to do that. But before we go there, let's try out different colors so that we know that it is working well. So I will keep this in the front, but it will be hard to see. Okay, let's try to put it here on the side, and I will try to run that. Okay, so this is the selection mode. I will select blue, and now I will draw with blue. Then we have the green mode, the selection mode, and then I will draw with green. Now I want to show you something else. If I don't put this part, if I don't put the first frame condition, what it will do is it will draw a line from the very start. So if I bring it here, okay, this is very annoying. We need to fix this first. Okay, let's say I am, here's my hand, and then I start drawing. There you go. So did you see? It started from the 0 point and it drew all the way to the current point. So whenever you have the new point, let's say I go to the blue one and I select that, you will see that, okay, not now, but in the previous one, you saw that whenever you have the first frame, then it will create this problem. So we are going to open that up so that we don't have this issue. Okay, next we can also try the erasing part. So the black one should erase whatever we have drawn earlier. But what we can do is we can make it a little bit bigger, because if it is bigger, it is easier to erase. So let's first select. So let's draw. And now I will go to the eraser and I will come here, and you can see it is erasing. But this is not very good because it's very small. So what we can do is we can have a special condition for the erasing. So we can write here that if the draw color is equals to 0, 0, 0, then we will have the size different. So here we will copy this part. Actually, we will copy both of these, and here we are going to write that instead of the brush thickness, it is the eraser thickness. So we will write here eraser, and we will also write here that this is eraser thickness. So we will go up, and here we are going to write eraser thickness is equals to, let's say, 50. So it will be easier to erase. And here we can simply write else we do this. So that should be good. So if we have the eraser tool now, so let's draw, and now let's go to the eraser tool, and it's a little bit hard for me because I'm sitting very next to the webcam, and there you go. So I can erase now very easily, and all of this will get very nice and very good looking once we do it on the original image. The only thing is that we have two images now, and it is very hard to see what is happening. So now all we need to do is we need to put it on the original image. So we need to draw on the original image. So how can we do that? We cannot draw on the original image because it refreshes every time. So instead of doing that, we are going to add our two images. So what we can do is we can go down here. So here what we can do is we can write here that image is equals to cv2 dot add weighted, and then we have to give in our image, the first image, and then we give in the value 0.5, let's say, and then we give in the second image, which is image canvas, and then we give in the value, let's say 0.5. So this will add these two images and it will blend them. So let's try that out. Oh, there is an argument missing. There you go. So if I draw, you can see now it is drawing. Again, I need to go back a little bit. Okay, so now you can see it is drawing. When the hand is really at the back like this, it will draw well. But because I'm very close to the PC and the camera, it is hard for me to do this. I can go back a little bit, and there you go. But the issue here is that this does not look very good. I can change these values, but still it will be a blend. It will not be an actual merging of the images. The colors will not be that bright. There will be a transparency on it. So if you don't want that, what can you do? Now, it is a little bit complicated, but if you break it down, it is very simple. So what we will do is we will write here, where is the statement? It's here. Okay, so we need to go here, and we will write here, first of all, we are going to create a gray image. So we will write here image gray is equals to cv2.cvt color, and we are going to say that image canvas and cv2 dot color underscore bgr to gray, tr to gray. So we are converting it into gray image. You might be wondering, wait, why are we converting it to gray image? I will explain in a bit. Then we are going to convert it into a binary image. Then we will write here image inverse is equals to, now we are converting this into a binary image, and we are also inversing it. What does that mean? I will explain as well. cv2 dot threshold and image gray, and we are going to write 50 and 255, and then cv2 dot threshold binary inverse. So the idea basically is that we want, let me actually run it so you can see better. So let's say I draw something. Let's say I drew this, and now I have this image. So what I want to do, I want to convert this image into black and white. So wherever I have black, I want it to be white, and wherever I have this colored image, I want it to be black. So what this will do is, it will create a mask with all this white and only this region as black. And then I will go to this image, and in this image I will make all of this black, and then I will merge this image with this previous image with the black area. So it will overlay these two. So I know it sounds a little bit complicated, but you will see how it works. So first of all, we are creating that inverse image so that all that region where we drew, it is black. Then we are going to write here that our image inverse is equals to cv2.cvt color, and we are going to write that our image inverse is basically cv2 dot color underscore gray to BGR. Now we are converting it back because we want to add it to our original image. So we cannot add it if they are not the same dimension. You cannot add a gray image to a colored image. So we need to make sure both of them have 3 dimensions. Then we are going to do image is equals to cv2 dot bitwise and we are going to add our original image with the inverse image inverse, and then we are going to add our image is equals to cv2 dot bitwise or, and then we are going to write image and image canvas. So again, this might be a little bit confusing, but let's see the result, and I will go step by step and explain it as well. So now here you can see I can draw. Oh, it went out. Here you can see I can draw easily. It's not updating this value, it seems. Yeah. Okay, it's not updating the value. Okay, so this is drawing on the canvas now, which is good, but actually on the original image, but the issue is that it's drawing this straight line whenever it is detecting again. So what is happening is that whenever the hand is detected, we should put this XP and YP as 0. So we will copy this part, and whenever the hand is detected, then we will make it 0. Actually, no, whenever the hand is detected, no. Whenever we start drawing again. So yeah, whenever we start drawing again, or whenever we have a selection. Whenever we have a selection, then we are going to do that. Okay, let's try that. Yeah. Now it's starting from the right position instead of a random position. There you go. So that is good. So let me explain what is happening at the back end. So first of all, we have our gray image, and then we are converting it into an image inverse. So let me display that image inverse. So this is our inverse image. So wherever I draw something, it is going to draw, but with black area. So let's try that. So as you can see, it will draw with that black area, right? So that is the idea. Then the next step is that we add these images. So we are adding with and, we are adding the image inverse and the image. So let me show you how that looks like. So I will remove this part and we will run it. We will see here that when we draw, you will see that now it is showing us black region wherever we drew. So all we have to do now is we have to add this image to this image. So when we add this, because here we have colored part, here it's black, here we have colored part, and here it's black. So if we do an OR operation between these two, it will give us our final image. So here we were doing an AND operation with the original image and the image inverse. Here we will do an OR operation to add these two up. And there you go. So now it's moving around, and the flickering you can improve if you have a better detection, if you don't have a lot of noise. So again, it cannot be completely uncontrolled environment. The environment should be a little bit controlled to have some good results. So if I go back, you can see I can draw a few things. And then if I go to the eraser, and I select the eraser, it will rub quite a bit. Again, my conditions are not very well, but you can get the idea. And if I want to increase the size of the brush or the paint or whatever, I can change it from here. I can make this 100 for the eraser thickness, and it will erase better. So here, if I draw something, and then I can do this, and I can go to the eraser, and then I can erase. You can see how simple that is. Hey everyone, welcome to my channel. In this video, we are going to create an AI-based mouse controller. We will first detect the hand landmarks and then track and click based on these points. We will also apply some smoothing techniques to make it more usable. So here we are in our PyCharm project, and we have created it by the name AI Virtual Mouse. So what we have here is the hand tracking module. Now, if you have not been following, we have written this module from scratch. So from the very beginning, from the very first project, we have added a lot of different methods to this particular class. So now the thing is that in our previous project, we added the fingers up method and the find distance method, and this will allow us to very easily create this new project. So we will have a look at that, how we can do that. And this file, of course, will be available online on my website. So a lot of you ask, how do you access the code on the website? You have to log in and you have to enroll to get access. And of course, it is free. Just enroll and you will get the access. Now, if you have not been following, you have to go to File, Settings, and you have to go to the Interpreter, and you have to add the OpenCV Python, and we have to install it. And then we also have to install MediaPipe, through which we will get all this hand tracking functionality. So MediaPipe, and we are going to hit install. Okay, so now both of these are installed and we can hit OK. So the first thing we will do, we will go and create a new Python file, and we will call it AI Virtual Mouse Project. Okay, so what we will do is we will first import CV2, then we are going to import NumPy as NP, and then we will import our module, which is hand tracking module as HTM, and then we are going to import time. Now, apart from all of this that we have been doing earlier as well, what we will do is we will also add a new library which will allow us to move around with our mouse. So with the Python script, we will be able to move our mouse, we will be able to click on it. There are a lot of these that you can use. The one we are going to use is called AutoPy. So we are going to hit install on that. So an error occurred. So let me check again if we can install it. Okay, so it was giving an error earlier, but then I clicked on it again and it installed fine. So we can close this and we can go back, and now we can also import AutoPy. Okay, so the first thing we will do is we will run our webcam to see everything is working. So we will write here cap is equals to cv2 dot video capture, and we are going to write that our video ID is 1. Now you will use 0 if you have one camera. I have multiple, so I'm using 1. Now the second thing is that we have to have a fixed width and height, so we cannot leave it to the default of the camera. So we need to change our width and height. So we will write here cap.set, and the prop ID for width is 3. Then the prop ID for height is 4. So we will make it 480. So that's how you can define the width and height. Actually, what we can do is we can put them in variables because we need to use them later on as well. So let's declare our variables over here. So we are going to write here that our width of the cam and the height of the cam is equals to 640 by 480. And we can just input these values here. So this is the height of the cam. And then we can simply go, let's remove this, and then we can simply go and write while true, we are going to say success and image is equals to cap.read, and we are going to get our frame value. So once we have this frame value, then we are going to say cv2.imshow, and we will say that our image, and then img, and then cv2.wait key and 1. So this is pretty much that we have been doing in all our projects. So let's run this and see if it works. There you go. So now you can see my webcam and there is my hand. So that is all good. So next what we can do is we can add our detector for the hand tracking. But actually, let's discuss what are the steps that we are going to take today to create this project. So the first step will be, let's put some numbering as well so it is easier to remember. So the first step will be to find the hand landmarks. So that will be the first step. Then the second step will be to get the tip of the index and the middle finger. So the idea is that if we have just the index finger, then the mouse will move. If we have the middle finger up as well, then it will be in clicking mode. So if it is in clicking mode and if the distance between the two fingers is less than a certain value, then we will detect it as a click. So you can bring your fingers together and it will click. So in that mode, we are not going to move the mouse, but in the index mode where we are moving, that is the only mode in which we will move. So what we can do here is that our second, our second step will be to get the tip of the index and middle fingers. So once we have the tip of the index and middle finger, what we will do is we will check which of these fingers are up. So we will write here number 3, check which fingers are up. Then in the fourth step, based on this information, we will check if it is in moving mode. So we will write here only index finger, which means it is in moving mode. So we will move our mouse, and if it is in moving mode, then we are going to convert our coordinates. Now, why do we need to convert? Because our webcam will give us a value of, let's say, 640 to 480. So for my screen, I have a full HD, which means 920 by 1080. So we need to convert these coordinates so that we get the correct positioning. Okay, so then, okay, it's bringing it back. We can change that later. Then we will add another step to actually smoothen the values. So why do we need to do that? So that it is not very jittery, it doesn't flicker a lot. So we will write here smoothen values. So we will smoothen these values, and once that is done, we can simply move our mouse. So move mouse. Okay, so this might seem a lot, but these steps are very easy. Some of them are single lines, some of them just 2 lines. So don't worry about these. Then number 8 will be to check if we are in clicking mode. So when both index and middle fingers are up, then it is clicking mode. So once it is clicking mode, we will find the distance between these fingers. So we will find distance between fingers, and if the distance is short, then we are going to click. So we will write here click mouse if distance short. So these are the 10 steps we have to follow, and the 11th and 12th step is fairly easy. So the 11th step is the frame rate, to see if we are getting a decent amount of frame rate, and the 12th step is to display. So we have already done this display thing, so we do not need to do anything more in that. Now what we can do is we can go on to the frame rate. The frame rate is very simple as well. We have done this quite a lot of times by now. So we will simply write time.time, and then we are going to write FPS is equals to 1 divided by C time, which is the current time, minus the previous time. And then we will write that the previous time is equals to the current time. And then we will write cv2.putText image, then our string, which we will first convert it into integer, and then we will write our FPS, and then we are going to write the position. So we will write 10 and let's say 50, or let's say 20 and 50. Then we will write cv2.font plain, and then let's say put the thickness, or this is the scale, let's put it as 3, and then we have, okay, we need to go back. Then we have the color 255, let's keep it blue, yeah, and then we will write 3. This is the thickness. So if we run this, we should have here p time is equals to 0. So if we run this, we should have our frame rate. There we go. So that is quite good. Okay, so next we have the frame rate, we have the display. Now we are going to do the actual part of all of these steps. So first of all, we have to get the landmarks. To get the landmarks, we have to declare here the detector. We have to create the object. So detector is equals to htm.hand detector. And inside that, do we need to add something? We can add, for example, the maximum hands, because we are only expecting 1 hand. So we can write here 1. and the rest we can keep same. Then here we are going to go down and we are going to write that our image is equals to detector dot find hands, not fingers up, find hands, and then we are going to find the positions of these hands. So we are going to write here lm list and the bounding box. So this is something that we added in our previous project, and we will write here detector dot find position. I think the spellings, detector find position, and then we will write image. So we are sending in our image, and that should detect it, and it should also draw. So let's run this and see if it detects. We have an issue. Find hands. Oh, we have to give it the argument of image. My bad. Okay, so there you go. So now we are detecting our bounding box, and we're detecting the fingers and the landmarks as well. So that is pretty good. So we are done with step number 1, and now we will check that if our length of our lm list is not equals to 0, then we are going to get the tip info. So we can actually put this up here. So here we will write x1 and y1. So these are the points of the index finger. So we are going to write lm list, and we will write that it is point number 8, and we want from the element number 1 and 2. So we will write it like this. The same thing we will do for our second finger, which is the middle finger. We will write x2 and y2, and here instead of 8 we will write 12. So this will give us the coordinates of our index and middle fingers. So we do not need to draw these at this point, so we can just print them out. If you want to see, we can print x1, y1, and then x2 and y2. So we can print those, and we are getting an error. X1, y1, not enough values to unpack. Expected to got 1. Why is that? lm list. Let me check here. What is the issue? This is find position, yeah. And this is lm list and bounding box, yes. So that should be fine. Okay, let's print out the lm list first. Print lm list. Let's check that. Yeah, we are getting some values and they seem fine. Oh, okay, my bad. Should be 1 1 and colon. Okay, there you go. So now we are getting the points. There you go. So now we are getting all these points. So for the index finger and the middle finger, if we move them around, you can see the values, they change. Okay, so this is good. We are done with our second part. Now we will go on to the third part. Check which fingers are up. Now this is extremely simple because we have already created a method by the name fingers up. All we have to do is we have to call it. We will write here detector dot find fingers up, and we will store it in fingers. So we can push this in, and let's print out. So print fingers, and we will remove the print from here. So let's run that. So there you go. So all the fingers are up, all of them are closed. 1, 2, 3, 4, and 5. So we are getting these values. So that is pretty good. Now let's go to the next step, which is, okay, let me push all of these in. Okay, so step number 4 is only index finger moving mode. So now we need to check if only the index finger is up. So we will write here, if fingers at 1, which is the index finger, is equals to 1, and fingers at 2 is equals to 0. So this is when the index finger is up and the middle finger is down. So this will be moving mode. So now we need to move our finger. No, we need to check where our finger is moving. So we get those points and we send it to the mouse coordinates. Okay, so first of all, what we will do is we will write here that we need to convert. So here we are converting our coordinates. So we will write here that x3 is equals to, we will write np.interp. We are going to convert one range to another range. So here we are converting the x1 value, and the initial range is basically from 0 to the width of our webcam. And then the second range is from 0 to the width of the screen. But we didn't get the width of the screen. Now I know that my screen is this size, but it could be different for yours. So in order to get the exact value, what we will do is we will go up here and we will write here that our width of the screen and the height of the screen is equals to autopy.screen.size. So this will give us the size of the screen. So if we remove the print from here, and if we remove this statement and all of this, yeah, so then we can print this, print w screen and height screen. Okay, let's run this, and there you go. So now you can see it's telling me it's 1920 by 1080. So this is the idea. Now that we have these values, let's comment this. Now that we have these values, we'll go back here and we are going to continue that it is from 0 to the width of the screen. So the same thing we will do with the height. We will copy this and we will write here y3, and then we will write here y1, and then we will write here height, and then height. So this is the idea. So these are the points that now we have converted, and now we will send this value to the mouse. We will smoothen these values, but we will do that later on. First, we need to see what is the original result, and then we can convert it. So here we are going to write autopy.mouse.move, and then we are going to write that our x3 and our y3 are our coordinates. So let's try this and see what happens. So you can see my mouse here. If I bring in my hand, and this is my index finger, and now you can see it is moving. But the problem is when I'm going to the right, it's going to the left. So this is very annoying, and it is very, it's not intuitive. So what we will do is we will flip it. In order to flip it, we just need to flip the width. So what we will say is, we will say that whatever the width of the screen is minus this. So now if I go to the right, it should go to the right. So the image here will be flipped, but in reality, I'm moving to the right and the mouse is also moving to the right. Now if I move to the left, the mouse is also moving to the left. So this should be easier to work with. So that is good. What we can do is we can draw a circle so that we know that we are moving the mouse. So here we can write cv2.circle, and we will write image, and then we are going to write x1 and y1. So we want to draw on that, and let's say 15 is the radius and the color is purple, and then we will write cv2.filled. There we go. So let's run that. Yeah. So now whenever we are in moving mode, then it will show us this big circle so that we know that we are in moving mode. Okay. So this is good. So now one of the issues here is that when I'm moving, I can go up very easily. It's not that bad. It flickers at the top much more than in the center, but I can go there. But if I want to go down, it's very hard because the hand is not detected properly. Again, if I move down, you can see it's not detecting properly and I'm unable to go down. So what we can do is we can set a region where we want to detect the movement. Instead of the whole image size, we can set a particular range. So how can we do that? First of all, let's create that range. So we will write here cv2.rectangle, and we will set in our image, and then we are going to call this, let's say, frame. So this will be a certain value, for example 100 or 200, something like that. So we will call it frame reduction, and we will also again call it frame reduction. So we can go up and we can declare it here. Frame reduction is equals to, let's say, 100. So we will write here, this is basically frame reduction. Okay, so that should be good. Now, once we have the frame reduction, what we can do is, now we need to give in the second value. So this is the initial value. Now we need to give the diagonal points. So we will write here that the width of the cam minus the frame R, and then the second point will be the height of the camera minus frame R. Then we will give in the color 255, 0 and 255, and then we will give in the thickness. So this will draw a rectangle. So let's try that. So whenever we are in, it's not drawing anything. Oh, it is. Yeah, whenever we are in, okay. Okay, maybe we need to put this outside. So we can put it outside here because we always want to see it. Whenever we have the hand in, we want to see it. So now you can see we have our box. Now the idea here is that when I reach the top of this rectangle, it should be, the mouse should be at the top of my screen. And when I reach the bottom of this, it should be at the bottom of the screen. So, and same thing for the corners. If I am moving at this corner, it should be at the corner. But now you can see it is not at the corner. So again, you can adjust these values up and down. We will keep it in the center for now, but later on, if you want to, you can adjust. So how can you reflect this on our X3 and Y3? So how can you change these values? So all you have to do is, it's very simple. Instead of 0, you will write here frame R. You will write here frame R. And here you are going to write width of the cam minus frame R and height of the cam minus frame R. That's it. So now your values should reflect properly. So here, if I have my finger at the top right corner, you can see it reaches the top right corner. If I have it on the other side, you can see it's reaching the top. And now if I go back and I go down, you can see it reaches down. So we are having some issues as well. It's going out of bounds. We can fix those issues later. What we can do is we can push this up as well a little bit. so that it is easier for our fingers to move around. But we can do that later. We can move on to the next step, which is to detect the click. Okay, so then we are going to detect the click. So here we have to check if both the index and middle fingers are up. So we are going to copy this part and we are going to paste it here, and we will write 1 and 1. So if both of them are up, then we need to find the length of between our fingers. So what we will do here is we will write that our detector dot find distance between which points? Point number 8 and point number 12. So these are the landmark IDs. So landmark 8 and landmark 12, and then we will write image. Then it will unpack the values of length and then the image, and then the, what did I do here? It should be comma, and then we also get a bunch of info that we are going to ignore. So the main thing that we need is the length. So we need to know what is the distance between these two fingers. So what we can do is we can write here print length, and let's try it. So when we are in our detection mode, it is giving us the length, and it is telling us there is a good indication because it actually gives a center point as well, and it draws a line in between. So that is pretty good. Okay, so what we can do next is we can check that if the length is below a certain value, then we will detect it as a click. But we need to define that threshold. So we are going to go back and let's try it out. So here it should be open, here it should be closed. So I can see it's around 30 something. So if it's less than 40 maybe. Yeah. Okay, so we can say if it's around less than 40, then it is detected as a click. You can do a normalization here as well, but that will be quite detailed, so we're not going to go into that. So we will write here length is less than 40. Then we are going to cv2 dot circle. We are going to draw the same circle that we had drawn here, but this time we are going to draw it in green. So we have the detection that it has been clicked. So let's try that. So here, there you go. We could draw it to the center one as well. It will look better. Okay, how can we do that? Basically, this is the information we are getting for the line. So we can write here info line, or we can write line info. And then based on this line info, if we go to our find distance, you can see CX and CY are the last elements. So this is the fourth and this is the fifth. So we will write here, this is the fourth and this here is the fifth. Push it down. Okay, so let's run this, and hopefully this time the center one will be green. There you go. So now it looks a little bit better. So that's good. Okay, so what is next? Now we actually need to click. So rather than just changing it to green, we need to click, and the clicking part is way easier than you think. And that is autopy.mouse.click, and that's it. So now it should click. By the way, these two we are already doing, so we should write here that we are checking the distance here, and then we are clicking the mouse if the distance is short over here. So that's the idea. Okay, so let's try it. So what I will do is I will try to click and minimize this part here. So here is my finger, and if I move around and I click, you can see it's shaking a lot. Yeah, it clicked. There you go. It clicked again. But as you can see, it shakes a lot. So this is a very big problem, which is not allowing us to use this properly. So what can we do? As I mentioned before, if we go up here, we can smoothen the values. So how can we smoothen the values? So what we can do is, instead of sending in exactly the same value, that, for example, if it goes from 0 to 100, instead of saying go to 100 directly, we will dilute it a little bit. So we will smoothen it, we will reduce its value, so it goes step by step. So what we can do is, first of all, we are going to create a value called smoothening is equals to, let's say, 5. So this is a random value that I've chosen. Later on we can see what is the effect. Okay, so now what we will do is, we need to also create two variables. So what we will do is, we will write here, in fact we need to create more than two variables. So we should separate the variable declarations here. Yeah, that should be fine. Okay, so what we will do is, we will say that our previous location, we will call it previous location of X, and the previous location of Y is equals to 0, 0, and the current location of X, and the current location of Y. So again, these will be 0 and 0. So what we will do is, what did I do here? So what we will do is, we will use these values and we will update them each iteration to smoothen our mouse. So here we are going to go here. Now, instead of X3 and Y3, we are going to send in the smoothened values of current location, and we will update our previous location. So how can we do that? We will write here that our current location of X is equals to our previous location of X plus our X3 minus our previous location of X divided by the smoothing value. So whatever the value is, we will divide it by that. And the same thing we will do with our Y value. So we can write here Y. You can multiply with this as well. You can multiply smoothing as well. Then you will have to go into points. So 0 0.1, 0 0.2, or you can divide and keep it whole numbers. It's up to you. So we will write here Y3, and then we will write Y, and then we will write, that's it. Okay, so then we will just send in our X value and Y value instead of X3 and Y3. And then we will just update these values once we have used them. So we will write here previous location X and previous location Y is equals to current location X. Okay, let's put Y first. Current location X. Okay, so that is the idea. Now let's put a very dramatic value, let's say 20, and let's run it. So now you will see, if I move it around, you see it is quite smooth, but it is quite slow. So we need to find, you see, when I stop, it takes a while to stop. So what we need to do is, we need to find a good balance. So let's try 5. So I like this. It moves nicely and it stops. It doesn't shake a lot. There you go. I can click as well. There you go. And let's click on the minimize. There you go. So yeah, that looks good. Let's try 10. Then is good, but it's a little bit slower. Yeah, it's hard to stop at that point. Yeah, 10 is a little bit fast. It is a little bit slower. So maybe 7. Yeah, this one is better. There you go. I can do that. I can go to this one. I can click on this one. Then this one again. There you go. So it is pretty good. So that is quite nice. So that is pretty much it. As you can see, it works quite well, and we broke it down into different steps. And when you go and try to solve each of these steps, it becomes very easy to get a solution. And all of this is possible thanks to our hand tracking module that we created earlier. If we don't do that, then it will be quite difficult, and it will take quite a lot of time to actually create such a project. But as you can see, it was quite easy and quite simple what we achieved in this short amount of time. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up and don't forget to subscribe, and I will see you in the next one.